Nicole,
Yeah.
do you have contractors that are waiting on the live?
Yes.
You said one's in New Mexico?
Yes.
Pretty early for them.
All right, you're live.
Sweet. What's up, everybody? My name's Jared. If you don't know me, I'm the Senior Technical Advisor for ACiQ. I'm also our lead trainer. A majority of my job is helping ACiQ on the technical side, whether it's with upper management, sales, parts, anything that encompasses the ACiQ world. I try to help bridge the gap between technician and ACiQ in general. I spend most of my time training our internal tech team that you guys talk to every day. If you call into the ACiQ tech line, those are the people that I'm helping. I even do live consults, so if they get into like a really big problem, they can basically come to me and say, hey, I got this weird thing going on. Have you seen this? Have you heard this? I also handle talking to our engineering teams that manufacture the product to try to get solutions out in the field for people like you. So today's class is mostly always, or all of it's going to cover mini splits. On the last class, I know a couple of you guys went to it. It was mostly unitary, but today it's mostly mini splits. There's obviously a lot of content when it comes to mini splits. I try to shorten it to the stuff that actually matters to you guys. I have a couple of components that we'll go over, but overall, it's mostly about mini splits. Does anybody have any dying questions that they want to ask before we go into it? Sweet. All right. So what we'll see here is that we have some basic information, technical features, control, protection, troubleshooting. I moved it around a little bit. So some of the technical features, I did put some troubleshooting in there, but that's just the outline of how this is going to go. The first thing I want to go over is these pamphlets. So our marketing team made these pamphlets that go over our single zone and multi-zone systems. The reason I want to go over it is because it does highlight some key features that you need to understand about this. You're going to hear me say this a lot probably, but we encompass multiple manufacturers. And what I mean by that is not every manufacturer builds and develops these systems the same, right? A lot of what you will learn is applied to every manufacturer, but it's not just manufacturer specific. And what I mean by that is on our single zone pamphlet, we have the Essential series. This is our Essential single zone series, 454B and R32. It's technically not our standard and hyperheat, which is what we're going over today. This is a single zone, wall mounts only, up to 35 or 36K. That's it. It's made by a company actually called TCL. And then when we get into what we're going over today, our standard series and our extreme series, it's all Medea made products. So this will be single zones, mini splits, 1-to-1s is what we call, usually obviously one indoor and one outdoor. And then we have multi-zone units, which have multiple heads. If we go down to the single zone chart, this is really important because what it actually shows is these units and what we offer for the multi-zone unit. So all of these are single zones. And what you need to pay attention to on this chart is when we go to the multi-zone, you'll see that specifically when we get to 36K, you're going to see these units drop off. And the reason why is because on multi-zone, usually 24, there are some cases where 36, you can do that, but usually you cannot put a 36K or above on a unit. So you're not going to be putting a 48K on a multi-zone unit. It's not going to happen. And there are some things in place that will prevent you from doing that. It's a call that we get sometimes, and I'll go over that when we get to multi-zones. However, when it comes to single zones, we do have single zone options that can cover up to 60K, including that floor mount over there in the corner. That technically is a 60K. It was here when I got here. It has a 60K hyperheat single zone outdoor unit. 48s, 60s, and then 36s all come in the single zone variety and single only. There's not too much. There's a lot of specs here for most of you guys who are quoting jobs. This might be important if you need to know anything when it comes to dimensions, try and get it through ADEX or whatever it is, what its rated BTUs are. Obviously up here you have your model number and what that equates to. If you scroll down, you'll see that. For those of you who haven't seen this, it's actually pretty good. We use it quite a bit in tech. But we do have a multi-zone system brochure. And as I was saying before, At the beginning, we have our Essential Series. The Essential Series are not made by Midea. This is actually made by ACiQ. We carry two sizes, the 18K and the 24K, and we only carry 3 indoor units, the 9, the 12, and the 18. That's that unit over there on the far side. That's it for that, and it's only wall mounts. Then, of course, we have our flagship product, which is our standard multi-zone unit. You'll see the ES denotation for that. If it's ACiQ, that's our hyperheat. You're gonna see that down here. And then you'll see the multi-zone condenser lineup. This is where you'll start to see all of our slim ceiling cassettes, concealed ducts, 4-way, all of that stuff will only be Midea. When you go down to the chart, you'll see, like I said, the chart is significantly smaller. You're gonna see that it goes up to 24K. The only thing the chart is missing is the multi-positional air handler. That you can go up to 36K, but that's about it. It goes over all the dimensions and everything there. Now, why is that important and how do we differentiate that? What you'll see is if you try to put, let's say for example, a 36K concealed duct, if you try to put that on a multi-zone unit, what you in the field are gonna see is that unit will not have 1, 2, 3, 4 that you're used to. What will it have? It'll have S1, S2. It'll be 2-wire only. That is to prevent you from actually sticking it onto a multi-zone unit. It uses 2-wire communication, so what you'll actually run for that is either 14.3 for L1, L2 and ground to the outdoor unit, and then 18.2 shielded to your outdoor to indoor unit. Once again, 1-to-1s only. So just remember that if you guys ever try to sell a job and you need something like a 36K or 48, you're not doing it on a multi-zone unit. It's the main reason why I have these brochures in there, is to actually understand what you can put on there. With that being said, we're gonna hop back over to the actual PowerPoint. You'll see that we do have obviously a large variety of these things. It's worth noting here that the one-way cassette, the 6, the 9, the 12, it's actually all one unit. You change a dial switch for capacity on that unit. It is the only unit you need to do that for. And then the 18 is just the one-way cassette. We do have wall mounts that go up to 36 on the single zones. And then, like I said, the air handler is 18 through 36 only. Once again, they go up to 36. So with that being said, we do have the 3-zone, the 4-zone, the 5-zone, and the 6 zones in 48 and the 55Ks. You can see the dimensions there down at the bottom, a lot of the specs. Most important thing for you guys, I think, if you haven't seen this, this will be your first introduction to it, is our multi-zone air handler compatibility chart. It gets kind of messy, but I want to try to explain it in the best way that I can. But basically, if you go down to the chart, you're going to see our contents here. You're going to see all the different models that we have for the 454B. You're going to see the units that can fit on that. All of them are there. This also calls out the adjustable capacity of the 60612, right? And then we have our wall mount units. More dimensions on the outdoor units, the piping, how many pipes it has, what are the sizes of the outdoor service valves. And then we get into the combination charts. This is extremely important, and it should be the very, 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 very first thing that you do. It's the very first thing I try to get techs to do when you get on a call with somebody. If somebody calls in and says, you know, I have an ACiQ 55Z, and I have 2 24s, an 18 and a 12, it should ring some bells to you to say, that's a lot. That's way, way, way over. The general rule of thumb that a lot of manufacturers go with is 125% normally, and then 60% minimum. So these units, you shouldn't put a, you know, with the 55Z, you shouldn't try to put a 9K on it and just run it. That's not gonna work. You need to try to at least get to 60%, and this chart will help guide you there. So it's put into a couple of categories here. We have the wall mount, you know, ceiling cassette and concealed duct. If you have these, this is the chart you would use. Also want to note here that the concealed duct is a high static concealed duct, and it should be considered an 18K. If you have a slim ceiling cassette, this is the chart you would use. If you're only using concealed duct, this is the chart you could use. I'm not going to spend a massive amount of time on this, but you can basically go through, find the unit you're working on, and then if you have 2 or 3 units, try to find it on there. If it's not an approved compatibility option and you're having refrigerant performance, there's not really a lot you can do. You're not going to force this thing to do what you want it to. Even having them all on there can cause high temperature discharge or low pressure or some sort of issues. The chart splits it up into what you actually have, but just be aware that it's like if you have the slim ceiling cassette or you have the air handler unit or both, right? That is a different chart for each one. So knowing what you have is important. If they're all wall mounts, then you can just use the top chart. And then you can keep going. And then, like I said, it gets pretty expanded as you continue going down and all the different combinations that you can have for everything. But the chart you need, you probably are going to need to find. And like I said, if you have a slim ceiling cassette or you have a ducted air handler in the combination, use the appropriate chart. And you should start there, especially when troubleshooting or heck, even selling the job. I'll send all of this to Nicole. She can send it to you guys. You guys can use this as your reference point. It's also uploaded on the portal too. So this is the working parameters. Like I said, I'm not going to spend a massive amount of time on the actual data. If you want to review this later, you can. But there is some installation requirements as far as like max elevation. We get this call a couple of times. A lot of this stuff, as most of you know, is on the submittal. This is going to be maximum distance, the distance between elevation. If you need to add charge, it's over here on the right. Get my pointer here. What you actually add, if you have a specific distance, if you go over the capacity. Speaking of adding charge, the rule that they use is every single port gives you 25 feet. This is pretty much universal across the board, at least for all of our products. That's about how it works. So if you have a 5-zone, obviously 25 times 5, you have 125 feet to work on. A question that we get a lot too that might be worth noting is we have people that ask us, well, what if my indoor units have different liquid line sizes, right? This is something that people ask. I have a 1/4 inch, I have 2 1/4 inch ones and 1 3/8. The biggest unit will get the priority of your factory charge. So if your first unit is 100 feet, it's gonna take 100 feet of your factory charge. So you're gonna charge for 25 feet of that, whatever's left on your biggest unit for the 3/8, and then the other ones, you're just gonna act like you had no factory charge, right? The biggest units will always bully the smaller units. They have a higher capacity, they have a higher value, they can start the compressor faster, which you'll see as we get into some of the more in-depth data. The bigger units will always bully and get priority over the small units. So they will, oh, we do? Yep, hit me.
Yeah. So Jason on the job wants to know, how's your compatibility with zone systems?
So on the mini splits, we don't usually zone them, I guess is the answer to that. I guess the ducted air handlers you could zone. They would be fine probably to zone. The only thing I would warn you is when you have the ducted air handler, it's extremely important to know this. There's 2 things that's going to make it hard to stick on a zone system. Well, not a zone system, but stick on a home system, I should say. The first one is that if you're trying to replace like an existing air handler and put this one in its place, you're normally not going to have 14.4 ran to that location. That's going to be your first hurdle to climb. So you have to get 14.4 there to power the air handler and to communicate with the outdoor unit. The second thing you're going to have to do is you're going to have to insulate that liquid line. We'll go over that as soon as we get into the actual refrigerant process, but in a normal unitary unit, you don't have to insulate it because you have 2 metering devices. When it comes to mini splits, you only have 1. So they're both hot or they're both cold. So if you want to zone that, that would be fine. When it comes to zoning, there's 2 things that you should always consider, especially when it comes to this stuff or unitary zoning. We don't usually advise on doing it because it's usually never done right, as you guys in the field have probably seen. The first thing I would do is a minimum of 2 zones, try to make them the same size, and you need to utilize a dump zone. It's very important to understand you cannot bypass because you are going to change that pressure, you're going to trick the sensors, it's going to cause a lot of issues and you're going to get bad performance and you're going to blame the equipment. So dumping it somewhere else, whether it's a basement or a mechanical room or something, is what you need to utilize for that. It's a good question though. These are the pipe adapters that come with the outdoor unit. For those of you who have done an install, you've probably seen them. It's a bag of adapters that allow you to adapt the 3/8 to half or the half to 3/8. This just goes over the part number itself and the quantity of bag of adapters that you get with that. Now, you don't need to use them. However, if you do have one that, like I said, you're doing, 4 9s, you're going to have to adapt that 1/2 inch probably to a 3/8 gas line. And if the compatibility chart has it, you normally have enough adapters. With that being said, mini splits are a little bit different than normal units. On unitary units, we normally adapt at the coil inside. Mini splits, we always adapt outside. The line set matches the indoor heads, and that is pretty universal across all of them. We make our adaptations on the indoor or on the outdoor side for mini splits. On here, on our units for the multi-zone units that are made by Medea, we do have these master valves, right? A call that we get a lot is people not opening them. I did put in a drawing here that is really, really important. It's something I use for training a lot. We get a lot of questions about where those master valves are, what they do, how they work, and what is in between the master valve and the service valves, right? This is a big, big question that we get. Technically, it's a little bit of refrigerant. So if we look at this chart, what you're going to see is if you have your port here, all you have is basically a little bit of refrigerant into this one. This also brings up the million-dollar question of why do mini splits only have one port? It's a fantastic question. It's one of the very first questions I ever get. What's up with that? Why are we doing that? Why can't I put a port on the other side? What if I decide I want to put a service port on the second side? I want to stick it in my line set, braze it. I'm going to put one there because I want to see it. Well, you're going to be disappointed to see that those pressures are going to be pretty much the same. This goes back to what I was saying about not having 2 metering devices. When you have 2 metering devices, you have a dedicated liquid line. And what I mean by that is it doesn't matter if you're in heating or cooling, that skinny line will be your liquid line 100% of the time. So when we're in heating mode, obviously we send our hot discharge into the house to reject heat into the house. Then we bypass the indoor metering device. We are now a solid column of liquid going to the outdoor unit to then meter to absorb heat from outside. If we're in cooling, it's a little bit easier. You guys obviously probably know that. But of course, we discharge into our outdoor coil. We reject heat outside. We bypass that metering device and we go in as a straight column of liquid straight into our EEV, which then meters inside so we can accept heat from the indoor unit and come out as a fully vapor straight back to our compressor. Now on a mini split, that's not the case. You have one EEV. So the only thing that's actually happening inside your coils is a phase change. We're just going from a liquid to a gas. That's it. There's nothing else. So this brings up to my point that I was telling him is that both of your lines are going to be cold. This is why you have to have insulation on both of the lines because we only can meter outside. And what I mean by no dedicated liquid line is because you got to imagine if we're going to meter here and send obviously the low pressure liquid into the house, we're going to come back as a vapor, right? But if we're going to meter the other direction, we're going to discharge inside, we're going to come back as liquid, and we're going to meter out here. So no matter what, you don't have one just spot that you know will be the liquid line. With that being said, this slide actually does bring up an interesting point. We get this a lot where people will ask, what do you want me to do, right? Do you prefer if I install my first one, pressure test and vacuum at the first one, and then do the second one, and then after everything's in a vacuum, I open up this valve and then these valves? And the answer is, yeah, if it was up to me and I could choose to force everybody to do it, the answer is yes. A big call that we get that causes a lot of problems for techs in the field is putting the line set and the electric in the wrong spot, right? Crossing those will cause usually one unit to freeze, but when they're both on, everything works great. It's a really, really common call that we get, and this usually happens when you do a install on a 3-headed system and you bring all 3 line sets and all 3 electric whips to the unit, and you can't really see where those go, right? They might go up one chase straight into the attic, and you don't really know which one's Alpha, Bravo, Charlie. You just kind of have to figure it out, right? It's not impossible to figure out post install, but it of course causes a callback, which we all know we hate, and it causes that issue. So if it was up to me, we do have a couple of contractors who have specifically told their techs they are not allowed to do more than one head at a time. One head, one pressure test, one vacuum. Outside of that, why do I say it? I say it because if you decide that you're gonna do all three at once, right? So let's say I hook up my first one, I hook up my second one, I hook up my third one, and I go ahead and release this charge that's in here. It's a de minimis. I release it before I vacuum. So I open up all these valves, boom, refrigerant shoots out. I hook up 1, 2, 3. I open up all 3 valves. Now I'm gonna pressure test from here and I'm gonna vacuum from here. It's not illegal, but what you're gonna actually run into is, let's say you have a leak now, right? Let's say one of your flare fittings are leaking inside. Which one? What, do you know? No, now we gotta go through Alpha, Bravo, and Charlie. We have to do them all at the same time. That's gonna be where you're gonna run into a problem. If you would have just done Alpha down here and just did it, you would know. If you were pressure testing just Alpha, you would know the leak is in Alpha. If you do it all at once, you're gonna have to go through all of them. And that's gonna be the biggest hurdle that you're gonna have, is that you don't know, especially when you have multiple units. We get this a lot where people just can't find it because you're not narrowing it down. So at the very least, what I tell people is, I prefer if you pressure test each individual unit to check for leaks. If you wanna pull one vacuum, once all of the service valves are open and you release that little bit of charge that's inside of here, I'm cool with that. But pressure test is where you're gonna run into hurdles, and it's going to extend time because now, instead of knowing it's in Alpha, you now have to go through all of them. Especially if you have 6 heads, it's gonna be a nightmare. So those are my piece of advice for that. We normally don't give a ton of install advice, but that's something that I have seen just from obviously talking to contractors in the field. With that being said, we do have the refrigerant circulation charts. There's 2 of them. We have cooling mode in a full load system. It's a pretty interesting chart. It goes over the refrigeration cycle and what we're actually seeing here. It also goes over some of the main components, whether it's like the metering devices or the check valves or anything that's inside of there. Like I said before, we are in cooling mode. We are gonna discharge to our outdoor coil, right? We're gonna go from a discharged vapor straight to a liquid. We're then gonna go to our indoor units. We're gonna meter, and then we're gonna go inside, and then we're gonna change just from a liquid vaporous mix to straight vapor. And then we're going back to our compressor, which you're gonna hear this a lot. A compressor is the vapor pump, right, into the accumulator. You're also gonna notice this is kind of new. If you haven't done much with the 454B systems, they do have electric ball valves. There is one of those on every unit. This is to try to seal off the system, right? We'll go over it a little bit later too, but basically if there is a leak, that ball valve is gonna close and your EEVs on this side are gonna close. If you just close your EEVs, that refrigerant's gonna find its way back over here. So you have to isolate the system, and it's gonna shut it down to try to prevent refrigerant from shooting in the house. The next slide we're gonna see here is a partial load. And what happens is, once again, our EEV is controlling our capacity. So if this one is not calling, we have this EEV closed, and then the other ones are running, and we're just coming back to the outdoor unit. It's worth noting that in heating, it's slightly different, right? Once again, we're gonna discharge out of our compressor through our reversing valve, out through here, discharge gas to a liquid, then we're gonna meter and go through. There are some situations where they use capillaries and EEVs, just depends on the manufacturer and depends on the unit. Usually smaller, cheaper units may use capillary tubes, especially older units, but a lot of our modern units are always gonna utilize the EEVs. Now this is an extremely important slide and something we get a lot. If you look at this, it's gonna be a little bit different from the cooling chart. You're gonna see that there is refrigerant going through that head. But why, you may ask, right? That unit's not calling. Why the heck do you have refrigerant going in there? It's a big question that we get. These units, and if you called in, they've probably told you this, these units have a 10% bypass in heating. 10% of the refrigerant will go to the head no matter what. This is a big call that we get where customers say, well, you know, I have a 24K and a 9K. The 9K is in the garage and it runs 24/7, but we are technically dumping 10% into that living room every time. Now you may ask why, right? Why don't we just close this down and just say screw it? The answer is oil. Okay, oil is very important. We need to get it back to the compressor. The other answer is it's easier when you're in cooling because you can stop it right here, right? When you're in heating, you're physically pushing it into those heads. And what's actually happening is if we close this down, you're still going to be pushing against it. So we do not want to push all of our oil and everything into this line, or if it migrated or you have liquid migration going inside of there, we have stuff getting trapped in there because we don't have the ability to put an EEV there to stop it. In cooling, you have that luxury. You do not have it in heating. So you will get a 10% bypass. This is why over or undersizing your units on a multi-zone unit can be a little bit detrimental, but it's only really detrimental in heating. And the 10% bypass, like I said, is what you'll normally see on that. Now, there are some situations where it will turn on the fan. Hopefully it won't. The 10% normally, for most people, it doesn't really matter. But some people will hear it, and you may get a nuisance that there's a little bit of refrigerant moving through the unit. This is the refrigerant circuit, just the diagram itself, once again, that goes over all of the different sensors and everything there. On this, we're highlighting the plate heat exchanger. So on the 60K regular heat and the 36K hyper heat, we have vapor injection that goes into the compressor. So what we do is we inject vapor into the compressor. This is done to try to help keep our head pressure high to help our efficiency in low ambient cooling. Or low ambient heating. It's only activated in low ambient heating, and it goes through something called an economizer. You maybe have seen this on these units, the little block plates, right? So what you're going to see is that normally the liquid goes through here and the vapor goes through here, and they exchange heat on that outdoor unit before it goes into the third port on the compressor, which is the vapor exchanger. Not every unit utilizes that. It's a common misconception. There are only a couple of them, and in this case, it's only the 60K regular heat and the 36K hyper heat. But it basically is a plate heat exchanger that can exchange a little bit of heat so we can inject a little bit higher of a temperature of vapor back into the compressor to help with that discharge temp, especially when it's extremely cold. With that being said, I do have some key components and some examples for you guys on this PowerPoint here. The compressors are DC inverter rotary type. The indoor fan motors are DC fan motors. The outdoor fan motors obviously are DC. The swing motors, so this is going to be our vane motors, or on the slim ceiling cassette, technically the filter drop runs off of those two. They're basically like an EEV, but they work in the same fashion of that. The four-way valves, believe it or not, are 240 volt coils. Now this is going to be something that's significantly different than what you're used to, but they are 240 volt coils, and they are energized in heating mode. The valve always rests in the cooling position. The electronic expansion valves are 12 volt DC pulses as well, same as the louver motors. That being said, EEVs, hot topic, right? Everybody's got something to say about EEVs. They got beef with them. Don't really understand how they work. They're kind of an enigma, right? With that being said, there's two pieces to understand about an EEV. Slide over here and grab it. There's two pieces to understand here, and the first one is the power head, right? So when we look at this, there's actually some notches for this, so we twist it, and then it comes off, right? This is the power head. This power head has teeth inside of it, north and south pole magnets, okay? And all we're doing with the EEV is we are sending pulses to each of those magnets to move this around. That's why you guys normally will hear when these units fire up, you'll hear that clicking. We're usually fully lifting it. Let's say if the EEV fully opens at 480 pulses, we'll usually send about 600 just to make sure it's open, and then we'll lower it. If you're calling for heating or cooling, we'll put it back in position. That way we know where it is. And then you have the part that actually touches the refrigerant, right? You have this little head, and then inside of it you have a pin that moves up and down. You're going to see it right here. Now this needle moves up and down, but all we're doing is just slowly grabbing this one at a time and going around. So since this is a coil, we can ohm this out, right? We can ohm out the coil, and those are the expected readings you should see. There are 5-wire EEV heads, and electrically we can test if it's right. Now, with that being said, before I get too crazy with the EEV, what I want you guys to understand is what is it actually doing, right? This is something that I go over with the team as well. And we are just maintaining superheat, but we're also opening and closing, obviously, the multi-zone heads. So a good example of this and what it actually does is I had a tech who came up to me and said, hey man, I want to condemn this EEV, but this tech doesn't have pressure gauges, but there's something weird. And I said, what? And he said, we're following temperatures. This is something, you know, if you work with me, it's something I do a lot. We're going to use clamps. Clamps are very important to me. We're following temperatures like you've taught us, and we have a clamp here and here. And right, nobody knows what that value should be, right? We don't know because you're going to have a significant pressure drop, and we don't have, obviously, the other side of the system to look at. But he's like, I have a clamp here and here, and it's 75 and 75. I don't have anything. It's not metering at all. This thing's bad. It's got to be bad. It's not metering even in the slightest. I don't have any pressure drop or anything happening there. And I said, well, listen, you need to tell the tech to get gauges. Let's get some gauges on that system, because what if there's no refrigerant in it? What if it can't induce a pressure drop because you have no refrigerant? What if my valve is all the way open, giving you as much refrigerant as you can, and you're about to condemn it because it's all the way open, trying to feed as much liquid refrigerant into that indoor head? Sure enough, guy went and bought gauges. Come to find out, 40 PSI in the system. The EEV never had a chance. The key with the EEV is we need to feed it a full column of liquid. An EEV is just a TXV. This is something we go over too, and TXVs obviously are kind of elusive as well. But understanding what the TXV's job is really important. The TXV's job is not to meter refrigerant, right? That is what it does, but that's not its job. Its job is to maintain superheat. And what is superheat? Superheat is the amount of refrigerant that's in our unit. So if we don't have enough refrigerant and we're about to condemn something, that's not going to help you. And obviously, like I said, in the end, it ended up being that he had virtually no refrigerant. I mean, not enough to cause a low pressure situation, but he definitely wasn't feeding the EEV enough. Now, obviously, that's not something that happens every time, but it's something to be aware of, is that you need to make sure that you're feeding it enough for it to even do its job. Because that's when you don't know if it actually is open all the way. Is that because it's supposed to be, or is that because you're not feeding it enough liquid? Two other components that are in this outdoor unit that are slightly different from what you've probably seen is the chassis heater. The chassis heater basically is a heater that is inside the bottom of the unit. It's activated during defrost. This is to help prevent ice from forming in the bottom of your unit and hopefully melt out the water that is in the bottom of the unit during defrost. It's activated, usually works a little bit before defrost. It's pretty easy to diagnose, right? If you notice that there's a ton of ice buildup in the bottom, it is, once again, you're gonna notice this is a theme. It is a coil of wire. It's the same as like a heat kit or the same as something else. It's a coil of wire that has a resistance. So you can actually take a resistance value on this and actually tell if it's good or bad, right? You can use the resistance, and we know it's a 240 volt, and you can figure out, actually using Ohm's law, what the value should be. Now, if you have OL, we're done, not much more to talk about. There's something actually wrong. Or if you have an insane ohm reading that's way out of spec, then you probably have something wrong. The belly band heater is the same way. This goes around your unit. The key here is, of course, during operation, we're gonna turn that off, and we're gonna turn it on to prevent liquid migration only, once again, in low ambient conditions. They're pretty straightforward. The next thing is gonna be our compressor. DC compressors are pretty easy to diagnose. The most important thing, of course, is all should be equal, and then there should be nothing to ground. It's very important. We get this code all the time. It's like compressor overcurrent protection, and people condemn a lot of boards for it. Normally, that always means the compressor is shorted to ground. Overcurrent usually is caused by shorts. Why did the compressor go bad? That's a great question. It's a great investigation you should do. Should be leery of acid in the system as well. If the compressor resin broke down and is now traveling through your system, You should try to obviously get that out of there, flush it through, do your best to protect it. But the compressor checks are pretty easy, and so are the fan motor 3 wires pretty easy as well. To itself, to ground, you're good to go. A lot of people want to try to test DC, right? They want to see a DC value. They want to do that. You're not really going to be able to do that. This isn't alternating current where it's on or off. There's usually a constant DC voltage that's sent to it, but the frequency at which those pulses are happening is what controls your speed. Frequency and speed are always correlated together. So the lower your frequency, the lower your speed. The higher the frequency, the higher the speed. That's how we're actually controlling it. DC on these units is made by inverters, right? So for those of you who don't know, we're basically taking alternating current in, we're rectifying it, we're sending it through a bunch of resistors and IPMs, and we're basically spitting out DC that's so fast that it technically is AC, right? It's kind of the same thing, and that's how we're actually controlling it. VFDs and stuff like that. It's what we're doing is trying to control that sine wave so quickly that it actually kind of comes out as AC. The next one is going to be fan motors. This is some of the stuff that I added because these are actually what you're dealing with in the field. This is going to be the 3-wire fan motor. Once again, the exact same as the compressor, no different at all. You'll notice because it has 3 wires. Shocker, right? UVW, it's the same thing. We need to just check the resistance. With all of this stuff, this one's going to be a little bit easier because you will have a mechanical check, right? We can see if the bearing is locked up. We can move the motor, see if there's play. You're not going to really be able to do that with the compressor. But for this one, mechanical check is usually, you guys have already done that before you called. You've seen if there's any ice. You've seen if there's a squirrel that got in there that got it stuck, right? So usually we don't worry about that. The electrical check is the next step, right? So U to V, V to W, and W to U. They should all be the same, obviously have no resistance to ground. So that's on our outdoor unit. Pretty much every single outdoor unit that you're ever going to run into is going to have that. And once again, same thing, usually fed by DC, and then the frequency is actually what controls the speed of the motor. The next one is going to be the 5-wire. This is going to be the most common motor that you run into on the indoor units. And for some reason, I feel like nobody really ever goes over what's up with the 5-wire motor. This one is technically a wall mount motor. It sits inside the wall mount unit like this, and there's a blower wheel that attaches to it, and it has 5 wires, hence the name, the 5-wire motor. The 5 wires are high DC voltage that comes from your board, 1 wire. Now, why is this a 5-wire? Is because this one actually has a baby circuit board that's inside of this motor, right? So you have the actual 3-phase DC motor, and then you have a little, it's called a speed control board inside of this motor. So this high voltage wire is actually split into 3 different windings inside of this motor. The key about this motor is if the board is bad, the whole motor is bad. You're not pulling this board off like you might do with, let's say like a carrier ECM module or something like that. You're not gonna rip this thing apart. If you smash it into pieces, you could probably get it out. And if you ever need to reference it, a lot of our stickers on the motors will actually show that. But anyways, we have our high voltage DC that comes in. This is gonna be what's powering our windings, right? The next one is black. It's a ground reference basically for your common on your meter. VCC. VCC is our voltage common collector. And what it's actually doing is just powering that little board. So it's usually 13 to 16. That'll always be a constant voltage, and it just powers the little baby circuit board inside of there. The next is VSP, which is a speed tap. Now this is gonna be our command to turn the motor on. For example, if you don't have that and the motor's not running, condemning the motor is not gonna do you any good. You have to ask the motor to turn on, right? So for example, if we do have that voltage and the motor's still not turning on and then you have a fan speed out of control, well, that's why. It's because you're asking it to turn on and it's not turning on. Once again, is it not turning on because there's a giant chunk of ice stopping the motor from spinning? You know, we need to do obviously our mechanical checks first, but once all that has been eliminated, why isn't it turning on? This goes to the very last point, which is the FG terminal. This is our field generating terminal. What happens is basically when this motor spins, it induces a voltage. That voltage is then sent back to the control board to know that the motor is spinning and what it's spinning at. that is how it's communicating, right, with the board. So for example, if you measure that you're actually asking it to turn on and it's turning on, but you're still getting a fan speed out of control and you don't know why, it's probably because something is wrong with your board and it's not sending the voltage back to your board. You should get FG every time that motor spins. And what's pretty interesting is actually you could spin this by hand and you will get FG as long as you're powering the baby circuit board. That is your feedback for these motors. That is how it knows that the motor is spinning, what it's spinning at. But it's a voltage that you can actually measure, unlike the other motors. Those three-phase motors do have the ability to see what it's spinning at, how fast it's spinning, but the easiest way to explain it is we only energize 2 windings at a time. The third winding on those motors is a feedback that's coming back. Of course, as you can imagine, this happens extremely fast, but that's the feedback for those. For this one, it's a simple DC circuit. It basically sends it back and says, yep, I'm spinning, I'm moving. Do you want me to go up or down? Yeah, let's go ahead and, move around and do whatever. So that's the dance, right? So this one's pretty cool because you can actually measure your command. You can make sure that it has high voltage, it has obviously the low voltage, and then you can see if it's actually sending something back. The next one, you guys are probably extremely familiar with, but believe it or not, this might blow your mind, there are motors that still use alternating current in this world. It's not super common. It's usually really common on older units, right? On older mini splits, believe it or not, they had capacitors. The indoor motors had capacitors. They're not using mini turbos, right? But they usually have a capacitor inside of there. Now the key with the AC motor is that it's split into 2 sections. I put a photo in there to identify something for you. On this side, this is our high voltage section, right? So we have the capacitor that you've seen in every drawing in your life running on the common circuit, and then you have your red going through here, basically just powering this motor. If we got 120 or 240, that motor should be spinning. If it's not, you got a problem, right? You have the windings that you're used to doing, right? The 2 should add up to the 1, same thing as, normal alternating current motors. However, on the right side of this motor, you're gonna see something that says FG. Might be familiar with what I just went over, field generation, right? And in this case, you have a couple of different things that you have on that right side. And try to get this out of here. Get this black out of here. So you have a ground reference. You have VCC, once again, which is your voltage common collector. That's powering the little baby motor or the little baby board inside this motor. And then you have V out, right? That's our voltage out. We can still use this type of setup and we can still get feedback from our motor if it's spinning. Once again, this can be proved by literally spinning the motor. As long as it has the voltage common collector voltage connected, it will actually give you a DC voltage if you spin it by hand. It's the same as that other motor, just with alternating current, right, instead of DC. Now, with that being said, the other thing to note with these motors is they also have this little piece right here. This little piece is a temperature sensor, right, that will break. You'll see it denoted right here. And it is basically a thermal overload. So if the motor is overheating because of bad bearings or because of something, it's going to open that up. So you may get a voltage out of control, and you may think, well, what the heck? I have 120 volts, but it's not spinning at these terminals. But the real question is, do you have it actually going through the motor, right? Is this circuit open because your motor is screaming hot, right? So that's the only other thing to note about that. TCL, I believe, is using those still for the single zone stuff. But Medea, I have not seen one of these in a Medea unit for a very long time, but it's worth noting that it does exist out there. Next thing I have is temperature sensors, right? Believe it or not, we do have people who don't know what a thermistor is. Just want to run through some basics of it. Get to that in a minute. Thermistors, the lifeblood of mini splits. So you have 2 different types of thermistors when it comes to our units that you're going to see, well, pretty much any units in general. is you're going to have the bead thermistor. The bead thermistor will usually end up in this little tube. Sometimes it's not. What it looks like is a little piece of like hot glue. This is usually used for ambient temperature sensor. So this is going to be this one is an example for a return temperature sensor. On those, it'll be up in the front corner. It won't be in a little sleeve. On our unitary units, it'll be inside the coil. And what you'll see is this is used to measure air. So outdoor ambient, indoor, anything that has to do with not being on something, you're going to see bead thermistors. They still work the same as every other thermistor, but they're a little bit cheaper than the actual pipe thermistors. Pipe thermistors are bead thermistors, but they have a little copper coating around them. They have a little bit of copper shielding, copper casing is the best word for it. Now the reason for that is because we want it to be a little bit more sensitive, because we're going to actually physically put this against something. So these are the ones that you see that slide into your coil, usually on the outside, or they slide into the temperature discharge, or they slide into the outdoor coil. So this is going to physically touch that. This is going to be live data that's transmitted to the circuit board for it to do its job, right? They're used to control the EEVs. They're used to know outdoor ambient for fan speed. They're extremely important, very easy to diagnose, right? These are non-temperature coefficient thermistors, so as you warm them up, your resistance will drop. There are charts at the very, very, very end of every service manual that you get. You can go and look them up. The key to reading these charts is really there's only two charts. You have your TP, which is your temperature protector for the temperature discharge. It's a little bit different. It's a lot more sensitive. And then you have all other temperature sensors, which is going to be our T1, T2, basically everything else. The TP is the only one that's weird. The discharge thermistor, it's going to be slightly different, so it has a different chart. Everything else will go back to that first chart. So what we're going to do, obviously, is we're going to measure it, and we're going to see its resistance in relation to what it is, right? If we're measuring the ambient temperature, for example, which is the easiest to measure, we're going to measure the outdoor temperature. We're going to measure the resistance. We're going to use the chart to physically find the degrees. It's 76 outside, and I'm reading, 10,000 ohms. And you're going to use that, and you're like, okay, that's obviously within good standing. If you ever get OL on those, obviously it's bad. Something has happened to the bimetal that's inside of here, and it's no longer moving. That's when you'll normally get a code. Or if it's not plugged in is when you're going to get a code. That will also cause the unit to kind of freak out and obviously not run the way you want it to. The next thing I have here is some pressure switches that I pulled. I feel like these also trip people up sometimes. We usually have one or two pressure switches. Usually they only have highs. A lot of our units have lows too, which is pretty cool. This one is a high pressure switch. If you ever want to know what it opens and closes at, you can actually look at the pressure switch itself, and you can see if the pressure switch should be closed or it should be open. That's millipascals. It's not something we use here, right? But you can convert that to PSI and know when it should open. So for example, this one is our high temperature pressure sensor. And anything below 464, it should stay closed, right? What we do is we send like a 5-volt signal down it, and if it get 5 volts back, we know it should be closed, right? So that's how this works. Your meter is doing the same thing when you do ohms. You're basically sending it feedback, and if you get 0, if you have a full path of continuity through it, well then you know the switch is closed. Our boards are doing the same thing. This one opens up at 638. Like I said, you can convert this in the field anytime. You just take this millipascals and just put it in a converter. Usually Google, you can say, hey, what is this in PSI? And it'll tell you that. Little sticker on it, which is pretty nice. There's not very many situations where we see that the switch is bad, right? If it's opening, it's probably opening for a reason. It's a matter of finding that reason. That's where, it gets a little bit more difficult. But there are some situations where they can go bad, right? If you verified that the unit definitely is not running at 600 PSI, or it just literally will never open again, and you have enough refrigerant in there, there are some situations where you can bypass this. That's not going to be a very common theme with mini splits, and that's why a lot of techs don't like them. We can't just jump them out and force them to do our bidding. But these we can. For some reason, I don't know why, but people want to either cut them and then jumper them here. That's not going to do you any good. I don't know. This is something that happened 3 or 4 times for some reason on a couple of calls that have happened recently. Jumping the switch itself will not do anything. You need to jump the board, right? We need to go on this side of the circuit. Jumping it here to here, you're not doing anything. It's still going to have that code, right? The only reason you could jump it and leave it out of the circuit is if you're waiting on one and you've fully confirmed that it is bad and it should be open, right? A good example of this is like if your high pressure is not closing, but you have plenty of refrigerant in there and it will literally never open again. I did take a call from one of our top dealers the other day, and that was his situation. It was not a new unit, but it would never open, and the unit obviously ran perfect after we jumped it. Then he set him a pressure switch. He's gonna have to pull it out anyway. So they are braze on. I know, boo. I wish they were flares, but they're not. So you do have to unbraze them. And once again, it's not as easy as we can just use a universal one, right? That's what we did old school. We would cut out the ones that are brazed on and we'd put it on our AC only. We'd just put it on the vapor side and move on with our day. Can't do that because once again, we don't have a dedicated heating or cooling side. Low pressure switch, same thing. You're gonna see that there's some writing on there to tell you when it opens and closes. This one is 43 PSI and above it should be closed, and then it will open when it gets to 20. Pretty low value, of course, right? But we also run pretty low ambient temperatures. So there are some situations where you could have freezing occurring and they don't want it to be a nuisance trip. It's really only looking to see if you have nothing in there to prevent that compressor from pumping and everything from running when you have absolutely nothing in there. There's some features that we can go over. I wanted to put this in here, especially for you guys in the field. We get this call every day probably, right? Are these units compatible with condensate pumps, right? I'm gonna put that wall unit on an interior wall and I wanna pump it somewhere else. The answer is yes. There is a way to wire it though that I wanted to at least bring up here. The key with condensate pumps, which is right here, the key with condensate pumps is that you need to power the pump. Hold on a second actually, before I do that. I really feel like we should have had a few more. Okay, cool. The key with condensate pumps is we have to power the pump itself first, right? So what you're gonna have here is that you have the motor, right? The electronics and everything inside of here. And then you have a float, which is inside of this little thing. Then you have your wiring. This is pretty universal across all condensate pump manufacturers. But the key to understand with this is we need to power the pump. So think of it, once again, as 2 separate circuits. We're gonna power the pump with the high voltage that's going into the unit. This looks pretty sweet because it can run off 120 or 240. You don't need to do anything different. We just get 240 to these 2. We have to power the pump. Now the next 2 are going to be our normally closed circuit and our common, right? This normally in every situation is going to break our line voltage to our head unit. So usually we're gonna run the one that comes from our outdoor unit through this circuit and go to our head unit. Now why is that? Well, because when the unit's running, if this float goes up and it stops pumping, right? If the pump dies or if you have some sort of issues, I wanna just kill power to that head. I don't want to break communication ever, which we'll get to here in a second, but I want to kill power to the head to tell somebody that, hey, there's a problem. So then when you go to that head and you go to 1 and 2 to see if it even has high voltage and you don't, great. Now we can investigate why. And what you'll do is look in the bottom and you'll find that there's a pump inside of it and it's filled with water. And you're like, wow, thank God that this was wired to break high voltage to tell this customer that there is a problem. Pretty universal across the board. But we're also going to see something that you guys might not be familiar with. And it's something we get a lot where customers want to put in wet switches. All right, this is not as hot of a topic, but it is something worth noting that they do make universal wet switches for these units as well. They look like this. It's a safe T switch. It's made by Rector Seal. They're pretty cool. They have a normally open and normally closed if you want to do it one of two ways. Has a little sensor here, little 2 prongs basically, and this sits on the edge of your drain pan itself. Once again, but we're still going to do the same thing. I put both of these instructions in here, and I also put a note here that we do not ever recommend using any wiring that breaks communication to our units. EL01 can throw you guys down a rabbit hole of problems. If you've ever tried to diagnose it, it is very hard. You don't need to add this in for another level of difficulty just for fun. Let's just do it the right way and break one of our legs of power that powers the indoor head and cause you to start looking for where you're losing high voltage. Losing communication, like I said, is not the way you should ever do this. Unless manufacturer specifies that, I would never recommend doing that because it is significantly harder. Now this one is, once again, the same way. We need to get power to it. So what you'll see here is we have power going to it, 1 and 2. Imagine that's just our high voltage side, and then our switch side going to the unit, through the unit, normally closed, going to 3 if you're doing the communication. Now, I obviously don't recommend that, so we're going to bring 1 through this to our head unit. When it comes to the indoor wiring, 1, 2, 3, and 4, for those of you who haven't been explained this, these indoor heads run off of 240 volts, right? They're all 240 volt heads. So for Medea, 1, 2, and 3, 4 is going to be our ground. 1 and 2 is going to be our high voltage. So step 1, do you have high voltage? 240 between 1 and 2. If the answer is no, why? Why don't we? Go over this a little more in depth as we get towards the end of looking at some circuit boards. But basically, 1 and 2 AC, and then 2 to 3 DC. Now what actually happens, just to explain it as easy as possible, is 1 and 2 is our high voltage. This is just powering our unit. And then 3 is actually our DC circuit, as you probably have measured before. However, 2 is our common. And what do I mean by that? 2 is actually our common leg for 240 volts, but it's also our common leg for DC. So 2 is actually carrying alternating current and DC together in harmony. It's holding hands with them, right? So we're using our common on 2. This is why I prefer if you break 1. Sometimes breaking just 2 can cause that DC voltage to keep that unit alive for some weird reason. I don't know why that happens, but if you break one of the 240 legs, try to break the one that's not the common. Now I say this because, once again, not every ACiQ unit does this. For example, and this is why looking at charts and looking at circuit boards is really important, TCL uses 3 as their communication line. And 1 is their high voltage, and then 3 is their common. But it's not every manufacturer does it that way. A lot of them do it this way, right? This is Medea's. This is what you're going to be most familiar with. But it's really important to look at the wiring diagram you're looking at to know what to expect. Something that a lot of newer techs get involved in and get a little squirrely about is they get really used to seeing 1 and 2, and they check that on a TCL unit. They don't get 240. Boom, we got a problem. But they don't actually investigate why, right? They're not looking at the wiring diagram to say, oh, a 1 is S. Oof, yikes. It's not even L1 or L2. So looking at the wiring diagram is really important and not getting into this belief that every manufacturer does it the same way, right? Before we leave this, let me go back, and I want to touch on one more thing. Why is that not pulling up? One of the last things I have here is a reversing valve. The elusive reversing valve, right? The maker of every restriction that you ever have, the problem child of it. I don't know why tech school doesn't do a really good job of explaining how these work or even how to diagnose them. That's why I wanted to at least go over this. Like I was saying before, reversing valves are powered by a 240 volt solenoid. This is going to be something that you're not familiar with. You're used to 24 volts. But you have to understand that mini splits don't actually have 24 volts. They're never getting 24 volts. They actually have 240 at their disposal all the time though. So we're going to use that 240 to actually activate our solenoid. It's not the same in Goodman's, right? We always have 24 volts going to them, so we can use 24 volt solenoids. Now, that's our first check, right, is are we getting 240 volts to the valve itself? What I don't want you guys to do is try to check this to ground, because what the engineers have actually done is use like a single pole contactor is the best way to explain it. And it usually will have some leg of 120 to it all the time. But if you unplug this or you back probe it and you don't have 240 or you have 0, it's not energized. Okay, it's very important to understand that you've got to have 240 for this to be energized. Pretty much universal across the board, that's what they're going to use, unless it's a 120 volt application, right? Then it'll be 120 volts because we have that at our disposal. Now, with that being said, I think the reason why it's most misdiagnosed is because most people don't know what it should be doing. A lot of people believe that this valve, if they just send 24 volts to it or 240 volts to it and the unit's off, well, I've just moved my slider over. I forced it myself. The answer is no, you didn't. That's not true. It's not true even in the slightest. What moves the slider is a pressure differential. So if your compressor is not running, you're not moving the slider. Now, some people may argue and say, oh, that's not true, man. I hear it. I can hear it smacking something. No, you're hearing the pilot valve. The pilot valve is a baby valve that sits right in front of the reversing valve. You're physically moving a little tiny reversing valve on the bigger reversing valve. That's the noise you're hearing. You're not moving this big valve. This big valve, like I said, has a baby reversing valve on the back that is physically moving and allowing the pressure differential to do it. Now, this slider, right, obviously has a tube that allows it to go from here to here and here to here, right? You're never, ever, ever messing with the top. Now, this means that there are some constants that we can tell you about the valve. The first one is that top is the discharge. Nothing more really to say about that. That's never going to change. If this isn't the discharge, you have problems. The middle is always going to be our true suction. And what I mean by that is this is always going to go to our accumulator, our compressor, whatever it is, and it's always going to physically go back there. The only thing that's going to change is your outside ones. So when I go to a reversing valve call, right, and like I said before, I'm going to talk about temperatures and following them and things like that. If you don't have enough refrigerant in the unit or you have refrigerant problems and you're bypassing your valve or something like that, that's not your valve's fault. You have to have enough of a differential to actually push down against this thing to actually seal it. So refrigerant, once again, is extremely important to actually making the valve not only move, but sealing itself. This floats. So what I like to do is when the unit's running, I like to take temperatures of all of them, right? Our discharge here should be the same as our discharge back. A great example of this is I ran this call with this troubleshooting with one of our techs, and we could not figure out why this unit wouldn't work. For some reason, it was a unitary unit, and we were getting like 72 degrees on the liquid line. Couldn't figure out what was really going on. So we started following it, right? We started following the pressures and the temperatures. And when we got to the valve, the discharge for some reason was 72. And I was like, wow, that is crazy low for discharge. If you guys have ever seen discharge, you know that's extremely low. But the discharge at the compressor was 147. You're probably thinking, how is that possible? Well, the answer to that is there's actually an oil separator on that unit. And that oil separator is where my pressure drop was happening. So just like a clogged filter dryer or clogged strainer or clogged screen, you can have restrictions that build up in between it. So just following that alone, we were able to identify where that restriction was. When you're following a restriction, follow your temperatures. 100%, it's going to lead you in the right direction. But you also have to know what this should be, right? So the other thing that we did was, and I draw this when I'm on the call with them, is we clamp it, right? What do you have at the top? 140. What do you have on the right? 138. Okay, what about the middle? 42. Far left? 47. Okay, let's move on. Not the reversing valve, right? They should be very close. They're not gonna be like spot on, right? They're gonna do a little bit of heat transfer around each other, but trying to condemn it without knowing that is a bad idea. And it's gonna lead you to do an extremely hard repair. If anybody's ever done one, you'll know it's the worst. It sucks, it's very, very hard.
We have a question.
Oh, you have a question? Hit me.
Diego asks, reversing valve on ACiQ
Yep, mini split. Yep. Oh, you're just trying to.
That was his question.
Yes, he's correct. So that's the single zone unit. That is correct. That's what you're going to have on that. This is pretty universal with all of them, right? It's not going to change too much, but yes, what he's talking about is the single zone unit. And yes, it's going to be that way. It's going to be that way on all of them. The other thing to note, and we'll get to it a little bit later, is that because there's only one reversing valve, you're not going to be able to have multiple units in multiple situations, calling for multiple situations. You can't have one in heating and one in cooling. They all need to be in heating or they all need to be in cooling. Most of you guys have seen mode conflict before. I'll go over that a little bit later. But with one reversing valve, that's really the only way you could do it. The only way that you could have multiple units is in a VRF situation where you have a branch box with a heat recovery unit. Then you can do it that way. But on all of our units that we sell, it is not possible. But yes, correct. All right, so going through that. Our units are multi-compatible. This is worth noting. The multi-zone units that say like Platinum air handler or the Hyperheat or anything like that, you can fit them on single zone outdoor units, like what he just said. The HP230B is a single zone standard heat outdoor unit. You can technically put any of those Hyperheat units, which is any of our wall mounts, so like ACiQ 09W-HH-MD, right? You can put that on a single zone unit, but you cannot take that air handler on the HP230B and put it on a multi-zone. It's standard only. However, the Hyperheat and standards can fit on the standards. That's what this slide shows. It shows that yes, you can put them on there. So you don't actually have to stock that. If you don't want to, you can technically use a Hyperheat. However, for ease and buying them one-to-ones, normally people don't do that. But however, don't go down the rabbit hole of thinking just because it's a Hyperheat wall mount that it's not going to work with that single zone, because it will.
And that was like all they had, they could throw it on there fast.
Oh yeah, absolutely. Yeah, if you get in a jam and you need to do that, or like I said, if you're troubleshooting and you're just lost in the sauce and you think just because it's not that HP230B indoor, it's not going to be what you're looking at. You're looking at the wrong thing. But yes, a jam is normally when we see it, right? They got to get it done. The next thing is pretty cool. Most of you guys might not have done this before, but these do have the ability to do automatic pipe correction. And what I mean by that is if you have A and B backwards, right, with the wiring, you know, I talked about that earlier, you can actually make the unit do a test by holding down that outdoor unit button. It'll display CE. And after, it's like 10 or 15 minutes, it'll basically try to correct where you went wrong, right? It'll run the unit, it'll see the temperatures, and it'll think, okay, well, alpha's definitely not running, but I'm asking it. So that must mean that Bravo is alpha now. Now, I'd highly recommend that you do this and only use this as a last resort. Quick way to figure out if you have your wiring in the right spot. A lot of people try to get kind of weird and squirrely and do weird things. It's so much easier than the way people make it. What I prefer if you would do, right, if you think alpha and Bravo are backwards, and you think alpha is the living room, and you think Bravo is the bedroom, but for some reason they are backwards, right? What I would prefer if you would do is just remove 1, 2, 3, and 4. Just remove them and see if the living room shut off. It's going to be substantially easier than trying to follow it or do all of that other stuff. If the bedroom shut off, okay, well, obviously that's the wire that you removed. At the, you know, like I said, if it's a last resort thing and you really can't figure it out because it's a weird walk or it's going to take you forever to do 6 of them like that, the automatic wiring feature, it's going to take a long time, but it can help you out of a bind there. But holding down that button, CE will be displayed and it will try to correct it yourself. However, I'd prefer if you would do it, but I understand that not every situation you can. There are some conditions if you want to try to do this. The outside temperature has to be above 41. It will not work if it's below that. Obviously, all the pipes have to be open. This includes the master valves and the actual service valves themselves. The unit has to be running for at least 2 minutes. So if it's obviously colder, you're not doing it. You'll see that right here, you'll see the switch. It's next to the LED there. You'll press and hold it. And on this outdoor unit, this is what that switch looks like. This is also going to be our check button for display information. This is going to be something a little more higher level that we're going to go over later. But you can get data from these units to get an idea of what they're doing / what they should be doing, right? Pushing that button can display parameters that will help guide you in this diagnostic process. Like I said, we'll go over it a little more later on what those should be, because it can get pretty expansive. But the service manual goes over it, and it is really important to actually getting an idea if the unit is actually physically doing what you're asking it to do. So before we go into electrical, I'm going to go ahead and pause here for a break, and we'll meet back in, what are you doing, Nicole? 10 minutes, 15 minutes?
Sure.
Sweet.
termites. My
Yeah.
Alright, so we have,
What's up, y'all?
we have a couple questions. Question number one is, given that all these components have circuit boards, why not connect them with common standardization bus for control and communication? For example, TCP IP network control or CAN bus? Especially, he says, especially given how inexpensive those embedded boards are these days.
So a lot of that, so to be honest with you, there are some ways that you could probably integrate some of that stuff. When it comes to our units, and we get this question a lot with Modbus, right? This is something, a building management systems that you add to our units. It honestly might be compatible with that, but here's my piece of advice for doing anything like that and putting it on our units. We will not be the ones to make sure that works. Who you buy that software from and who you purchase that equipment from needs to make sure it works with our units. However, a lot of our units are like Modbus communication capable basically, and can be controlled by like a centralized controller, which I believe is what they're getting at. But we aren't the ones to make that work, right? The person you purchase it from, the software manufacturer, needs to integrate that into our units, but they are capable for it.
Great. So question number two is this is coming from Brad Firth over at Ally. He said, is there a way to switch Fahrenheit to Fahrenheit when going through the outdoor board with the push button to see the temperature of everything?
There's not. There's not. That's a good question, though. Unfortunately, no. A lot of it is going to need to be converted to that. I wish there was. It'd be a sweet update. But currently, no. It does have the push button go through Celsius. And we'll go through that as we get to that part of it.
Okay, part two of his question is, if you guys could put a Celsius to Fahrenheit chart on the panel for converting, that would be awesome. If not, is there a way to do that?
Like a physical chart on the unit, like a sticker.
Yeah.
I mean, yeah, you could make any sticker you want and stick it on the inside of the unit, right? We as techs have the luxury of having the smartest device in the world in our pocket at all time, right? So I, of course, have an app that does it for you, and it is pretty easy to use there. But like I said, it's not utilized as much unless you're doing something like that, right? Unless you're doing an actual conversion from something like that. I would like if they would add that ability. It would just be kind of hard because the only ability you have is to pull data from that outdoor unit. So it'd have to be like, it can't be like a press and hold because then that's the automatic piping. But it definitely could be something we could look into. It's not super unrealistic, I don't think. All right, so we're going to electrical control. We've obviously spoken quite a bit about these units and what they have, right? This is going to show you exactly the sensors that we have in these units, right? Between indoor PCBs, we have communication going back and forth. They're sending data packets and basically telling the outdoor board what its fan speed is at, what the swing motors are at, right? Our louver motors work just like EVs. They're just mechanical versions with little gears that spin it up and down. What the T1 return air temperature sensor, T2, excuse me, is going to be our coil temperature sensor, and TS. TS is something that nobody really thinks about, but TS is what you actually have your thermostat set at, whether that's the remote or whatever it is. TS is used quite a bit to give capacity requests, force the unit on, right? And all of this is really, really cool to understand that a lot of these controls, which you'll see here in a minute, which like I said, I'm not going to spend a massive amount of time on it because it gets in the weeds a little bit, but usually it's going to be T1 minus TS, right? That's going to give us some data to then get a target to then turn on our compressor and do different things like that. But just remember that TS is what you have it set at. So if it's set at 72 and it's actually 73 or 74, that's going to be your differential between the two. TS is your set point. Now, just to kind of touch on this too, with the unitary units, we get this question a lot is, what if I use an Ecobee? What the heck is TS? It's a great question, right? Because Ecobee, right, we don't have a way to communicate what our request is, right? We don't have the ability to tell it Well, I have it set on 72 because it either is on or it's off. The indoor unit doesn't care. It just is getting that signal. This is where the return air temperature sensor on those units is extremely, extremely important, because TS is your last reading at the end of your cycle with a 24-volt thermostat. This is why you lose a little bit of efficiency, is because you don't have that TS in the living room, right? But you still can control the unit. TS is now the last input. The problem is if you make those units like a downflow application, right, and you don't move that sensor, this is why your unit might behave erratically. Or if you have a TLO4 or a wired controller, this is why it just short cycles with no error codes. It'll turn on, satisfy immediately, and then turn off. TS is extremely important for the algorithm to actually ramp up and down. We get this a lot, where a tech will come to me and he'll say, yeah, we have this KJR, and for some reason the unit will turn on for 3 minutes and then it'll shut off. And we'll just doing this over and over again. I'm not getting the code. I think it's a bad board. And I'm like, cool. What does it do in 24-volt mode? They're like, well, we tested it in 24 volt, works great. It ramps a little weird, but it works really great. It's like, let me guess, it's a downflow. They're like, how'd you know? I'm like, because you didn't move the sensor from the bottom of the A coil to the airstream above it. It's very important to do that on those units. So if you're doing horizontal left, you don't have to move it for the AHB series. You do have to move it for the PAH. And if you flip them the other direction, you do have to do it. But TS is very important for actually controlling the algorithm and giving it a target and giving it data live while the unit's running. So just wanted to bring that up. But this one, obviously the return air temperature sensor on like the wall mounts is in the front, and TS is what you have your remote set at. So this is where we get into like the capacity request, right? This is basically what it's doing to control the compressor and how we're actually controlling the compressor. I did leave a lot of this in here, but I basically just want you to understand a couple of things about it. Is that the indoor unit will scan the indoor unit request about every 20 seconds, and it will change and adjust based upon that, right? Capacity request is calculated according to TS, T1, and T2 and T4 in heating mode here. Those are very important to actually giving the compressor a target, right? If we go to the next slide, you're gonna see how do you actually calculate that, right? This will basically, like I said, the norm code, which is gonna be your T1 minus TS, your indoor unit capacity, and then a correction, basically the average outlet temperature. And then we'll go into more of the charts, right? These are the charts for heating and cooling, the norm codes, and the heat pumps size expressed in horsepower here. I need my laser pointer down here. This is the capacity request chart itself, right? The higher the capacity request, the higher the compressor frequency. Now, the reason that I left this in here is understanding how and why these things do what they do, right? And like I said, there's a lot more things that go into it, right? But basically, I said it earlier and I mean it, the bigger ones will bully the smaller ones, right? We get this call a lot where a customer will say, I have two 24s and I have one 6K. And for some reason, the 6K doesn't turn on really ever. It's got huge temperature swings. And the answer is, it's because you have that combo. It's not that it won't work. It's just that you have to understand that it's not gonna really perfectly maintain 72. You need a minimum frequency to actually turn that compressor on, and it doesn't have a lot of juice. And what I mean by that is, when it's 72 and it's only 73 in the room because it's warming up, that might not be enough of a differential to actually force that compressor to turn on, to send it basically to that. It's gonna wait a little bit longer because it knows the 24s are probably going to turn on, right? So that compressor adjustment will basically look, and it may even wait till it gets to 74 to then turn that on. Because if it turned it on, it's gonna short cycle it really, really, really fast, and it's not gonna run long enough to actually be a cycle for it. If it did that, it might only run for 1 minute and then turn off. So it's got minimum timers, right? And just the biggest part to understand this is that if you have like a big unit and a baby zone, it's not gonna be uncommon that the bigger zones, you know, obviously can turn it on whenever it gets 1 degree above, right? But the little one, it may have to wait a little bit until it can actually have enough of a call, right, to actually turn that compressor on. This is obviously very important when you're trying to figure out rogue situations like that. But it's also really important when you're sizing this to try to keep them closer in size and try not to oversize the outdoor unit. So for example, if it's like I said, the 24 and 24 and you have a 6, you probably could have got away with doing, you know, a 48 or something like that. Your outdoor unit is slightly oversized, which means it's going to need even more than if you just would have went with the 48. So just try not to oversize the outdoor unit, especially when you have little units. It's the biggest reason I left this in here. So you can see in this situation, this basically has a T1, a TS, 6-degree differential, the norm code is 3. And then this one has a 2-degree differential, the norm code is 2. But you can see that this is a pretty huge swing, 6 degrees, and it's only a 3. But this unit's a 12K, it's got 2, and it's already a 2. So like I said, my point is the bigger ones will always bully the smaller ones. They will always get the priority, they will be able to maintain better. So sizing your units is really, really important. Moving on to the different modes that we have, a little bit more data, right, on this to kind of give you an idea of cooling mode, heating mode, a couple of other things. There's an auto fan. If you change the fan speed, it'll change that. But basically, this is the performance charts for cooling. When the compressor starts, the initial fan speed is actually determined by the outdoor ambient temperature, and it's adjusted every 30 seconds. So you'll see that we have all the charts for it ramping up and ramping down. Cooling mode, this is our EEV steps. These are the open steps for each size, and these are pulses, right? So we're doing 300 pulses for the 18, and then it'll be adjusted according to T2B every 2 minutes. So every 2 minutes, it'll take another reading, and then it may send some more pulses or may close them down, may move them around depending on T2B. T2B is gonna be our return on our vapor line for the outdoor unit. T2, of course, is our indoor coil. In heating mode, obviously everything's the same. You can set it to high, medium, low. The indoor fan speed will change when it's this. The other piece that I want to point out here in heating mode, it's something that some techs get a little bit blindsided when it comes to heating mode. Trying to diagnose a fan motor and you're trying to call for heating, cooling, or anything is a really, really bad idea because most people forget that these units don't turn on until the coil heats up. I get this call a lot where people will be like, well, I'm calling for heating, but it never turns on. And it's like they're waiting 5 minutes, but what actually has happened is the outdoor unit still hasn't even turned on. So trying to diagnose the fan motor or trying to see something, you need to remember that there is an anti-cold delay, right? When the fan speed turns on, you have the anti-cold air function, and that's controlled by T2. So it will operate under those parameters. Like I said, a little bit more data on the delta T and all of that. This will depend on the return air temperature and T2. That's the curvature chart for high, medium, low, and it can be adjusted. Like I said, just a little bit more data. And then like you saw before, the outdoor fan speed is controlled by T4, which is our ambient air outside.
Jared, have a question.
Yes.
All right, so this question is Adam. He's saying, if you are using a ducted and mini splits together, is there a chart for that, specifically a hybrid?
Going back probably 2 slides.
Like as far as like a compatibility chart?
Yes, the compatibility.
The one I went over? Yes, so there will be a chart for that on the multi-zone air handler compatibility chart. If you're using the ducted air handler, and what did he say the second thing?
If you're using
Ducted and mini splits together.
Yes. Yeah. So you're going to see that chart. It's going to be labeled like this. So if you're using the ducted air handler combination, then yes, you can have a wall mount and stuff like that. This will be the chart that you use for that. It has its own chart. It will always have its own chart. The ducted air handler is kind of a weird beast, and it will have its own chart. The only other chart to note is if he's trying to use the ducted air handler and the slim ceiling cassette, there is a chart for those. However, if he's just got, you know, wall mounts or anything, console, floor ceiling, stuff like that, then he's just going to use this chart. And there's one for each size here. So he can go down and, if he's doing the 36K or whatever, yes, there is a chart specifically for the ducted air handler, and you'll see that right here. And that's the chart he would use for that. So this is the EEV pulses in the heating mode. These are the different opening steps, right? Pretty much the same as the cooling mode for actually adjusting it. There's a fan only mode. Of course, temperature control is disabled in this. Another thing to note is that your mini split, of course, will display your set point, right? You can't see what the actual temp in the room is unless you put the remote in follow me mode, which I wouldn't recommend that because a lot of people like to put it in follow me mode and then throw the remote in their neighbor's front yard or ship it to Canada. I don't know why, but if you put the remote in follow me mode, what you're doing is setting that remote up to be a thermostat, right? And with that being said, that remote has to stay within eye shot of that outdoor unit or of that indoor unit. So it's going to communicate every 3 minutes. And then, of course, the remote will display your ambient room temperature. However, it's smarter and it's easier, and it's a lot easier to diagnose if you don't have it in follow me mode because you only have to worry about the return air temperature sensor, right? So you won't see that. In the fan mode, you won't see anything except just the fan speed, right? The louver operations are all the same. You may see the temperature of the room itself, but you cannot control it. You have drying mode. I also don't recommend this either. Drying mode is a little odd. It's a little strange because yes, it will lower the fan speed, lower the compressor, and pull humidity out. However, the biggest problem we get into with this, as you guys have probably seen in the field, is that there is no temperature control, right? So if you're on dry mode for 90 minutes, it may, especially if it's oversized, it may drop it to 60 degrees in there. And to actually run a dehumidifying mode, right, we need to add heat back into the room. A dehumidifier specifically slightly actually heats up a room. Unless you have the outdoor unit inside the room that you're using in dry mode, you're not adding that same heat back into the building. You're exhausting it outside, right? We're moving heat from one place to another. So drying mode will actually not solve your problem and can't be, a permanent function because then once again, it's just your temperature is just gonna be out of control. These are the defrost conditions. I only reference this if you have defrost problems, right? These are the parameters in which defrost occurs. So at very, very, very minimum here, what you'll see is that the unit has to run for a minimum of 29 minutes. And this is the same actually for those units. We get this call a lot where customers will say, we just have ice building up and ice building up and ice building up, and it never runs into defrost, and I can't get it to run into defrost. If I manually press the defrost button and thaw it out, it defrosts just fine. The first thing I ask them is how long is their run time? And then I find out that they have a 5 ton on 1,000 square foot, and it only literally runs for 7 minutes every cycle. Okay, well, there's your problem. You cannot do that. That's your problem. Oversizing it is not the solution because what's going to happen is you're never going to reach the minimum requirement for it to even enter defrost. For it to even use these algorithms, you're not even meeting the minimum requirement. Now, I'm not saying you're dead in the water in that case. What I'm saying is you need to at least set up your thermostat like an Ecobee for like a minimum run per hour, right? Minimum run time, or spread out your calls, right? You need to try to find a controller that can do that. Obviously in mini splits, it's a little bit less of a problem, but it is good to note that you do have to run for 29 minutes before it even thinks about defrost. And then after all of that, it will do it if these conditions are met, right? Coil temperature and the outdoor temperature, and if the compressor has been running long enough. Those are the conditions in which it will actually activate defrost. So a little bit more data on will it enter defrost, if the compressor's runtime is long enough. Obviously the T3 is extremely important. It's gonna be our coil temperature sensor. If any of these are met, it will actually run in defrost. Once again, a little bit more data on when it exits defrost. If any of these items are satisfied, defrost or finished, the unit will go back into normal heat mode. It's basically to see if the coil temperature rises or the unit has been running for 10 straight minutes in defrost, it will pull itself out too. Auto mode, what a controversial topic. Auto mode on your remotes does not work the way you think it does. I don't really have like a major problem with auto mode. Auto mode has tendencies to like not turn on your electric heat on like the ducted air handlers or even the unitary units. So that's another reason why I don't recommend it. However, the second thing I want to point out in auto mode is that it will only cool if you're 2 degrees Celsius above your target. Now, what does that mean? That's usually about 4 degrees. So if I have it set on 70, it will not run in cooling until it reaches 74. Now, you guys may think that's crazy, but it's going to get a little bit worse when I tell you if you have it set on 70, it's not going to run heating until you get to 66. It is a huge differential. I don't know a lot of people who can deal with, a 6 to 8 degree differential, especially in auto mode. Usually the rule of thumb that we've always used in the field is like 4 degrees, right? 3 degrees like minimum. We do not want them to be that close together. Usually 2 or 1 is normally a little too much because we don't want it to heat and then kick on our cooling and then it just fights all day, right? So differentials are extremely important. But in this case, that's why we don't recommend it, is because that swing is huge. And this data really isn't presented anywhere, so it's really good to note. If customers chill with that, it's good enough for me. I mean, I don't care, but just be aware of that. Yeah. Well, they even have too. There is a way that you can actually put it in that, but yeah, that's really the only situation, right? Is where you're not going to really be around because it's not really maintaining comfort at that point. So we don't recommend doing that, and especially I highly recommend not doing it in any sort of testing procedure. If you're ever trying to test these units and you're forcing them to come on, you're going to be better served forcing them to be at 60 degrees in cooling or 86 degrees in heating. If we're trying to see if we want this unit to turn on, we need to make that norm code as high as possible. So when you go in there and you move it to 72 and it's 70 in the room and you want it to heat, it may not turn on, it may not force it to turn on. You need to try to do huge swings to get this thing to do actually what you wanted, right? If we're testing the EV or we're trying to make sure that something is happening or not happening, we need to add a significant differential, right? If it's a comfort thing, like I said, auto mode is a pretty high likelihood that they're trying to use auto mode and they don't really understand it. I just recommend staying in the cooling or the heating in that case. There's a little bit more data on the auto mode there. There's a couple of things that you can do on the unit too. There's a button on almost all of these units in the front. That button does 2 things. The first one is forced cooling mode. It'll run for 30 minutes. It'll force every single one of the units in cooling. All of them will say FC. So if you ever get that stuck, it's because something is telling it to go into forced cooling mode. Now, once it runs for 30 minutes in forced cooling, it will change to the second option that you can click that button for, and that's auto mode. The auto mode setting is 24 degrees Celsius, which I believe is 76, I think, and the units will just stay that way forever after that. If you put one in forced cooling, all of them are going to follow. They will follow your command on any of them that call for forced cooling. They will follow it. The same thing with auto if you put it in auto. So for example, if your customer lost his remote and he's got to get some cooling in his house, that's really the only situation that I could see where maybe you would be using the auto clicker or the forced cooling click or anything like that. Outside of that, obviously you have the remotes. But it is an option to click that button. So you'll see here after forced cooling, it goes into forced auto. You can also just click it and go into auto. You'll see that it's 75 degrees Fahrenheit roughly. And once again, that's auto. So we're going to go 4 degrees up and then we'll start cooling, which I don't know anybody who's cool with it being 80 unless they're super old. But if that's the case, they're probably not going to be chill that it's going to heat at what, 72-ish. But that's what it's going to do. If you change that, if you change it with the remote, it will leave forced operation mode. Auto restart function. This basically is that the unit will remember what it was doing before you lost power. So if I was in heating, I will go back to heating. the units will remember and auto restart wherever you left them. So if you think resetting them is going to get them to go to cooling all of a sudden, it's not. It will remember where you had it in the case that you have a sudden loss of power. The other thing that could happen, and you won't really know this because there's not really a denotation of this, but this unit can force itself to go into what's called oil return operation. Now, when does this happen? This usually happens when the actual frequency of the compressor is too low for too long, right? So if we have a couple of baby units and the big one never ran and it just is barely running and it's been running like that for quite a while, it may go ahead and ramp everything up and force everything to turn on to get the oil to come back to the outdoor unit. That's something that it will do automatically. Oil return, like I said, there's some more data on when that might happen, but it could do that. So if the customer says, you know, hey, my unit ramped up randomly and did that for a couple of minutes, it's not that uncommon. It could definitely just be running the oil back to the outdoor unit because it's been running in low load conditions for a while. Mode conflict, I touched on this a little bit earlier, but this is worth noting that, once again, you cannot have one in heating and one in cooling. So using these for like multi-tenant apartments is not a good idea, right? Because you're going to have the little old lady who wants it to be 80 and, you know, the younger guy who wants it to be 60 or 68 in there. You're going to have mode conflicts. This is denoted by dash dash. If you guys have ever been in the field and seen a dash dash and have no idea what the heck that means a mode conflict. That will tell you that, hey, one's in cooling, one's in heating, or one's in fan. Fan can cause a mode conflict. You can't just stick it in fan. If you see here, this is going to be a mode conflict if you have one in fan and one in cooling. You can't do that. If you're going to put it in fan, put them all in fan. If you're going to put them in heating, put them all in heating. But if you put them all in fan, it'll be fine. But that's another thing to be aware of. There's a couple of options here of what actually happens, right? When there is a conflict, it'll stand by and show you the conflict warnings, and then it will switch over if it needs to. Once you change it all back, another option or another case. Okay, outdoor check function, what we were just kind of talking about there with Brad. You do have the ability to pull data from these outdoor units. There's not a massive amount of situations where you will do this, but you do have the ability to do it. And what does that actually mean? It means that you can use this to help with your diagnostic process, right? A great example of this is if you think the unit should be doing something and you're trying to figure out why it's not doing something, this is usually where I go, right? This is going to be a pretty expansive list. Obviously, we're not going to go over every single thing. This is in the service manual. Obviously, you'll get this PowerPoint too. But it's worth noting that they gave us an example of a 6-zone, right? If you only have a single zone, this list will be significantly shorter. However, there's a lot of good data that you can get from this, right? When you see outdoor units or you see double dash or 0 or something, that's the normal display. When you click it, it'll pop up 01, and then it will tell you the number of indoor units. This is also really important if for some reason you think your wires are crossed. That will only help you if the capacities are different, right? If for some reason you have an 18, a 6, and a 9, you can try and track them down that way, right? Or, for example, if you're trying to figure out if that slim ceiling cassette was actually set up to be a 6K, because they come default at the 12K mark. So what does the outdoor unit believe the capacity is on that unit? So if you look and it's actually a 12, you're like, okay, so it was never set. It believes it's a 12. It's not true. And then it'll have a denotation of what it is. If it's 0.8, then it's the 7K, you have 6K, you have all of these different options, but these capacities will go through it. This is the capacity demand, right? This is our norm code. So are you actually asking it to run, right? This is where we can go to our units and you can see exactly what it's actually calling for. Couple of other things, and then we get into T2A, T2B, T2C, T2B. This is obviously your return line coming back to the outdoor units. This is a thermistor. This is what I usually use it for. This is what Brad is talking about. You're going to get this in Celsius. If the indoor unit's not connected, you're going to see a double dash. That means you don't have anything connected to Echo, right? This is where thermistors are kind of interesting. This can help you lead to maybe why it's not doing what you think. You could just check the thermistor, right? But this will help guide you to where it might be. So like, for example, if you have a bedroom that even if you put it on 60, it doesn't turn on, and you go out here and you see that for some reason your thermistor is reading 55, and you're like, what the heck? How's that possible? It's 74 in that room, I know. Well, this will lead you to actually figuring that out. It'll tell you, no, it's way too cold in there, I'm not turning on. And you're like, ah, okay, well that explains a lot. So then we'll go into the second list here. Like I said, you have T2 or T1A, right? If you go to 22, it will tell you what that one is. These are all the T1, so your return air. T2 is actually your coil temperature, like I said before. Condenser pipe temperature is your T3, so that's what your actual coil outside is. T4 is going to be our ambient. And you have TPs as our discharge. Could you use clamps to get all this? Yeah, sure. But you could also just pull it from that. There may be some situations if you're really, really struggling out in the field, there may be some situations where we actually ask you to pull this data. So we'll say you have a 24 and a 6K on a 36 or something like that. What we want you to do is turn on the 24, give us this list, right? And it's not going to be as long as this because it's a smaller unit. And then turn on just the 6K and see what it is, and then give us this list. And we can use this to actually see, you know, demand codes and different things like that. What are the sensors reading? Sometimes a good example that I've used for this is we had this customer who, for some reason, would not, the indoor unit, when it was in communicating, whether we were using 24 volt stat or whether we were using the communicating stat, it would not run in heating. We could not get the unitary unit to run in heating for the life of us. Couldn't figure it out. Put it in 24 volt mode, right? We did our checks, and what we found out was it still wouldn't run. I'm like, all right, well, last Hail Mary, we're gonna force the outdoor unit to run in 24 volt mode. Put the outdoor unit in 24 volt mode, and it runs fine. But the real question is why, right? Why would it run fine, but it would not run when I asked it to in communicating? And what we did was we pulled this chart. We said, give us both of those. So what I did is once we got the data, what I found out is for some reason, his indoor coil temp always read 160 degrees. However, when you take away the ability for that unit to see the indoor, it makes up a number. It'll make up 75 or something. You'll see that it's just like stock numbers, right? When it loses the ability to see that temperature inside, it doesn't know what the indoor coil temperature is. However, using this check function, we were able to identify that that's the reason. Your coil is hot. It's not actually, right? It's out of calibration. But the coil is so hot, the outdoor unit thinks, my coil's already hot. I'm good. I'm not running, right? So this will lead you to trying to figure out if it's, once again, doing what you want it to do. Like with these, we don't have the ability to like force it, right? But like I said, it can help you lead you to maybe why it's not, right? Is your coil temperature always 60 degrees, and that's why your indoor blower motor never kicks on and then it trips high head pressure, right? Is that why you think it's a blower or a condenser fan motor or a blower motor and you replace that and it still doesn't fix it? Well, maybe it's not turning on because it never sees the coil heats up, even though it actually is heating up. So those are very important inputs to this unit to do pretty much anything, right? You can also see your current, right, that's running through that. You can see your AC voltage of what the unit thinks. You can see your DC voltage, your opening angles. It's not super useful as much as you would think. The only time you may use that is if you're trying to see if like alpha head is even opening the EEV for it to turn on. If you have a demand code and it's not opening, that could definitely lead to a problem. You have frequency limit sensors, if there's any faults, the average value between all of your coils inside, outdoor fan speed, a couple of other things, target discharge temperature, capacity, and then the high pressure or corresponding temperatures, the outdoor fan speed little chart down here. And then the last one, I'll go to it really fast. Compressor stop, it's right. Compressor stop, right here, 49. 49 is reason for stop. We get this question a lot where you get to a customer's house and now the unit's running, but it wasn't running. People always ask, does it save the last codes? Can I recall these last codes? It's a question we get a lot. Short answer, no. The answer is really no, you kind of can't. There are some situations where you can, right? But no, you can't. You really need the customer's help to identify what the code was. However, there is one situation where you can do this, and that's here on 49. So if you get to a customer's house and, for example, she had a code, but she hit the power button and shut everything off. The last reason for that compressor to stop will be labeled on 49, which you'll see here. These are the reasons of why the last compressor stopped. Now, a lot of times, obviously, what you'll see is it just stopped due to defrosting mode switch, or it stopped just because the call was over, right? It shut down. It might not even be like a problem. This is why, like I said, if it's running when you get there, you're not going to be able to pull this data. But there are some situations where you may be able to pull that data. You may be able to see what it was if they left it alone and didn't touch it from there and the code is just gone. You can pull it up in that situation and see, oh, there was a fan speed malfunction. So there is that for that. There are a couple of protections, right? One of the major protections is a start delay on the compressor. That they say it's 3 minutes. I think it's somewhere around an hour, it feels like, when you're in the field. I don't know why, but it doesn't feel like 3 minutes. It really feels like 20. That's another thing that sometimes we get a call where people think it won't start, or it won't stop, or it won't do something. A lot of times they're just not waiting on a delay. I hate to say that that's something silly that happens, but it happens a lot. Especially with the outdoor unit, right? Is they're thinking that the 5 minutes has been up and now it's not doing what they want, right? Of course, there could be other reasons, but they sometimes just don't wait on the delay. I was in here with a guy yesterday, and we were putting one of those unitary units in 24 volt mode, and me and him were standing there, and after like 3 minutes, we were like, well, probably should be on now. And like 2 minutes later, it turned on. So my piece of advice there is just everything they do is slow. I understand it's going to slow you down, but unfortunately, you're not going to be able to bypass it. It will not. The second thing here is the temperature protection for the compressor itself. So this is going to be the discharge temperature thermistor. Discharge temperature is extremely important when it comes to inverter units, and protecting that compressor is the number one thing. High discharge temperature is one of the major killers of compressors, whether that's due to low refrigerant, dirty outdoor coils, burnout, anything like that. Trying to keep that compressor from cooking the oil inside of itself is extremely, extremely, extremely important. You're going to see this labeled as like TP, temperature discharge protection, or something like that. But just know it's very, very serious to take into condition, because it's going to keep happening. Another good example of you seeing that code is, once again, that one I said earlier, where you have 72,000 BTUs on a 48K or a 55K. Like a crazy number. Of course you're going to get discharge temperature thermistors. You're pushing this thing past its limits. And in that case, that was a call where we didn't start there. We had sent some parts, we sent even the discharge thermistor and a bunch of other stuff, but this only happened on high, really, really hot days, or really, really, really cold days. And it's like, well, yes, that's gonna be the most demand on the compressor. So looking at that, getting to the bottom of why that happens is really important. There's two things to tell though if your compressor has been overheating. The first one is there's a sticker on that compressor. Let me go grab it really fast actually, because this is worth noting. So this is our rotary style compressor. Once again, not super relevant to the type of compressor and stuff like that. But this is the compressor. There's a sticker on the compressor. The very first thing you need to look for if you think you have compressor damage or temperature discharge problems is this sticker will actually start to turn a different color. It'll actually start to turn black. I can show you an example. I saved this for a reason here, because I wanted to be able to reference it and show you what it kind of looks like if you see that. The second thing you'll see is that the jacket inside of the compressor blanket that sits around it, you may be able to see it on that one. It's like cloth, right? But you'll see that that jacket will actually discolor as well. That's the other indication that you've probably either demagnetized or lost some sort of, you have some sort of compressor issue. Sorry, I want to pull this up so you can see what it looks like. Parts chat, compressor. It's going to be pretty uncommon that the compressor will cook itself, right? We have the high pressure temperature sensor that should stop that. We also have the temperature discharge that should stop it. However, if there is a chance that it is, this could also lead to why you have a mechanical problem, but you may not have an electrical problem. Pulling this up now. Yeah, here it is. So a good indication that you've had some damage to the compressor is that that sticker is cooked. It will actually physically turn black. Heat to the compressor, like I said, will not only kill your oil, it'll destroy your oil in the unit, it'll break it down on a molecular level, but it will also mechanically damage your unit. This cannot be turned white again, right? Once this is cooked, you kind of know. If you look at this photo too, you might notice something, that our temperature discharge thermistor is sitting right here. What's up with that? I don't know. But these sensors can't do their job if you take them out, to the point to where, you know, they could definitely explode and shoot oil all over your unit. Definitely can happen if you take the temperature thermistor out and put it down there because it kept tripping. This is how you cook compressors, right? Bypass safeties, jump out the pressure switch because it's annoying and it keeps tripping. Take the thermistor out, and then your compressor is going to go boom at some point. It's not going to be able to handle that. So it's worth noting that you can damage them, and they're probably more than likely, right, not tripping just for fun. They're not tripping to make your day worse. It's tripping for a reason. That's why going back to the refrigeration cycle and doing your temperatures and trying to follow a restriction or whatever it could be could definitely save you from having to do a compressor. The second thing I want to note on these compressors is pretty much all of them have an accumulator. You'll see that little accumulator that is attached to the compressor itself. I didn't really go over that when we go over the compressor, but for those who don't know, an accumulator is a liquid to gas separator, right? Some of you guys might not be familiar with it, but basically what happens is most people think it's the storage tank for your unit, and that's sort of true, right? We can store liquid in it during low capacity operations, but its real job is to separate liquid and vapor from each other so your compressor only breathes in vapor. This is not really a compressor, it's a vapor pump. You get liquid back to your compressor, bye-bye. It's not gonna work. So you can't have zero superheat. Now, because we have an accumulator, this is gonna lead me into another thing that you're gonna run into. There are some situations where you're gonna wanna charge the unit based on superheat or subcool. You're gonna wanna do something like that. And I'm sorry to say, don't do that. And I'll tell you why. Here's a great example. When I fixed that unit right there, that 5-ton, we had a board issue in here. When I fixed the 5-ton, I had a 34-degree split in this room, which any tech would say that's insane. That's the craziest thing I've ever heard in my life. And it kind of is, but mini splits can do that. So when I hooked up gauges, right, we only have one side of the system. And normally your superheat and subcool values don't matter, right? And that's what every trainer will tell you. And that's technically true. In a bubble, it doesn't matter. However, in the grand scheme of things, it can help lead you to maybe what's happening, right? So for example, if you have the indoor unit freezing and you take a pressure reading and you get superheat on that, and your superheat is extremely low, borderline 0, and it's freezing, you more than likely have an airflow problem. You have a heat transfer issue at that point. Let's say it's extremely high. Well, then definitely that would lead me to think you're either low on refrigerant, the EEV isn't doing its job, or it could possibly be a restriction. We can use that to our benefit to actually get some information, but you need to know what those numbers mean. So what was actually happening with my unit and why I had a 35-degree split was because when I hooked up gauges and took superheat readings, my superheat was 0. Now you guys might think, of course, especially old school techs might think, that's not possible, big dog. That's a bad idea. You're not gonna have that compressor for longer. Well, I can run close to 0 superheat with that unit because of my accumulator. Now this is not the case with like Goodman's and a couple of other ones. Even if they have accumulators, we normally don't do that on normal systems, but mini splits will. So if you see you had 10 degrees of superheat and you want it to be 5 or something, you try and dump refrigerant into it, that EEV is gonna start closing and you're actually not gonna see the values change the way you want them to change because of the accumulator. We can run low superheat because our accumulator will protect our compressor, but we can't run low superheat if there's too much charge. Once you fill this accumulator up past its vapor entry point, which is about up here, you've got liquid coming back. And you got liquid coming back for a little while until it's done. It's not gonna break immediately, but it will break soon. You will mechanically destroy it. You cannot compress a liquid. It's one of the very first things they teach you. Liquid cannot get back to your compressor. It's over if that's the case. So protecting your compressor and looking at that stuff is extremely, extremely important. There's also sensor protections on the unit. So like I said before, you have like T1, TP, T2, all of that stuff. It will give you a code for that. You'll see the codes at the very end of the slides. But basically it'll tell you if a sensor fails. Now what it won't tell you is if there's a sensor out of calibration. That's when, like I said, you'll get that weird situation where you have it set on 60, but it's still not even running, but it thinks it's 50 in your room. Now those will be a little harder to find. That's why the point check function is really, really nice. However, it will tell you if it's open or it doesn't see it at all. Inverter module protection. This will be for voltage or current or temperature. What they mean by that is the inverter itself will protect itself if there is an overcurrent. We talked about this a little bit ago, but basically if your compressor is shorted or your fan motor is shorted or a rat chewed a wire and it's touching the housing of your unit, it's measuring current all of the time. And it's looking at it and it's saying, okay, current is good, we're gonna run, blah, blah, blah. We see this sometimes when the compressor is bad, the unit doesn't throw a code immediately. What it'll do is it'll run for 10 seconds and then it'll throw the code. It's because once we start sending that voltage and that frequency to this compressor, that short causes a massive spike in current and that board goes, whoa, 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 we're done. I don't know where the problem is, but something's happening. I don't really know what it is. It could also be because you have a loose connection. We've seen this where Molex connectors, the way they connect, sometimes they don't make a great contact. They might melt. You guys have probably seen this in disconnects multiple times in the wild where people don't torque them to spec or don't torque them down at all, and it just melts that. Bad connections can definitely cause that. One of the last protections, voltage is also one, right? So if you put a unit and your voltage drops off a cliff, you're missing a leg or something like that, it will shut down and it'll display voltage out of range problem. I think this goes without saying. For the life of me, please don't send 240 volt to a 120 volt unit. I've seen it every month probably, but people love doing that. I don't know what's up with that, but pay attention to the voltages on the side of the unit, the rating. And the last one is temperature. That board is monitoring the temperature of the IPM. the inverter module itself, that little board right there, that heat sink there is actually part of the refrigerant circuit. A lot of times it's part of the liquid circuit. And what it is it obviously is cooling the IPM. When we transfer this from AC to DC, that takes a lot of energy, and it takes a lot of heat, and that heat has to go somewhere. There are some situations where you'll see regular heat sinks, like in the airstream itself, but a lot of them have been seeing that if they have them in the airstream and the unit gets dirty, that clogs up that and that causes a control board failure. The refrigeration circuit's a little bit more reliable itself, but it is monitoring the temperature of that. So a good example of this is if you see IPM overheat protection, you should probably start looking at the refrigerant circuit. Do you have a leak? Do you have a restriction? Do you have some sort of problem with that? More than likely, it's not your board telling you that for no reason. It's telling you because you might have a problem with that. Or, like I said, if it's an Airstream one, is it dirty? No, my coil's not dirty, but then look up under it and physically look at to see if those aluminum fins are actually dirty. Because there definitely could be a spider web in the front of it or something like that that could cause low airflow, which would, of course, cause it to trip due to temperature. Fan speed out of control error. You guys have probably seen this a couple times. Those are when you have, either a feedback problem or a motor problem or a board problem. Kind of went over that when we went over the fan motors and how they actually talk back to the unit. Two things that it could be is, of course, it's not doing what it's asking, or it's doing what it's asking but not sending that feedback back. Or for some reason, something else is wrong. Like I said, if you have fan speed out of control and you go outside and there's ice everywhere and the motor's completely covered in ice, you're like, okay, it's probably not a fan speed here, right? Mechanical failure. But it does have those abilities to protect the unit from that. The indoor heat exchanger does try to prevent itself from freezing. We actually had a pretty recent conversation with the owner of the company and we normally don't see that it turns into a giant ball of ice unless your wiring is backwards. If your wiring is backwards, it really doesn't know why it's freezing. It can't even really tell it's freezing, right? It thinks that alpha's freezing, but it's really B that has the refrigerant, right? So it doesn't even have the right data. It'll never be able to protect in that case. But these are the parameters in which it will stop that. And of course, the temperature condenser protection, basically a coil temperature sensor if it gets dirty, or if something is wrong with the fan, or if you have some sort of problem, it will protect itself in that case too. High temperature protection, they're indoor evaporator and heating mode. So this is, for example, if you have the motor spinning, but the wheel's not on it. The unit's not gonna know that. We had a call actually the other day that was really, really bizarre. And it was this guy who was claiming that the compressor, or I should say, the unit just wasn't working, right? This could be true in mini split, this could be true in anything. This guy was saying that he had a code 42 outside, which mind you, 42 is not a code. 42 is one of two things. It's either your set point for your thermostat, or it's the frequency at which the outdoor unit is running. And then of course it goes away after it, tells you that. But he just kept saying that, but he was like, this was a unitary unit, and he was like, I can see both sides of the system, and it's 200 standing on both sides, but it's 42. I'm like, well, that's impossible. I said, is your compressor on? He was like, I'm drawing current. I'm like, oh. What had happened is the shaft broke inside the motor itself, but it was still spinning the shaft. Once again, the unit does not know that. It's sending feedback back to the board and it's saying, hey, I'm running. And it's like, cool, sounds good, until something else happens, right? We have a low pressure on the indoor coil if we're on cooling, or we have high pressure because the indoor unit isn't running. A good example I was just giving you was for if for some reason, let's say your set screw on the blower motor of a wall mount unit fell off and fell into the abyss, but your motor was actually spinning. Your indoor unit's not gonna know that. Your indoor unit just knows it's spinning. It doesn't know it's not attached to the wheel, but what's gonna actually happen? Well, your coil is just gonna heat up to the point to where it eventually has to shut it down and say, whoa, this is getting way too hot. Something's happening here. And that's one of the other protections that it has. One of the last protections is if you're using dry mode, it will stop if you get to 10 degrees Celsius, and it won't resume until it gets back to 12. Another reason why I don't recommend dry mode, because obviously that's very cold, but that's the other protection for dry mode itself. There are pressure protections on the unit. Once again, I kind of went over this with you guys on when they open and when they close, and then the suction pressure when they open and when they close. It's just a slide that goes over that exactly. There is one thing while we're talking about pressure that eludes technicians, and it's what this is. This is not a pressure switch. This is a pressure transducer. Most of you guys who are familiar with commercial, especially older commercial stuff, you guys have been using transducers for a long time. They're not new to the mini split world. There are some mini splits that don't absolutely use these, but usually every system will have one, and it's usually on the vapor side. So what is a transducer and why is it different from a pressure switch? Well, the answer that you're looking for is a transducer takes pressure into the copper side and it outputs a DC signal for the board. What do I mean by that? I mean that what we do is we send power to the transducer, we have our ground reference, and then we send a DC voltage back to the board. So we can actually tell that unit what the pressure is on the vapor port, right? Or on the gas port or on the liquid port or whatever it is. If we want to read it, we got to convert it to something that the board can see and recognize. You guys actually use transducers every single day in your life. It's called your field piece gauges. They're literal little baby transducers. All they're doing is sending a signal to a little circuit board inside your gauges, and it's sending it back and displaying it on your app. That's it. You'll have these on there, but some people think that these are like normally closed and normally open pressure switches. They're not. They should be fed a DC, and you should get a DC value back. But for people who don't know, you will see these inside of there too. And they're part of the way to maintain operation, to give the circuit board and the algorithm data on run speed and different things like that. They are not actually pressure switches. Just wanted you to know what that one was. High noise protection. Basically, on cooling or dry mode, if one indoor unit's operation each time the compressor starts, the unit's EEVs will open for about 3 minutes. This is to prevent the unit from causing the noise itself. Obviously, that situation could cause high humidity on the off unit and cause water dripping from that unit. It's not normally something we deal with too much, but it is a protection for the unit. There is another protection that everybody is going to love to talk about, and you guys, I'm sure, will be thrilled, and everybody will be doing backflips, and it's A2L sensors. A2L sensors are elusive, right? They're kind of weird. There's a lot of miscommunication about it in the A2L world and what the government wants manufacturers to do with these things. I'm here to tell you that I have to give you some bad news, that A2L sensors are not an open and close switch. I know everybody, we get this call a lot where they're just like, how do I bypass it? Or how do I jump it out, right? You're not doing it. You're especially not doing it on a mini split. These A2L sensors and all the ones that we use are 4 wires, okay? 2 of them are power, 2 of them are communicating. It uses RS-485 Medea Modbus communication to talk to the board to give data, right? We get another question a lot that's a little weird, and it's, how do they work? Some people think they work on resistance. It's a common thing we get. Some people think they work on different values, or how does it know, right? The short answer is, without getting too far into the weeds, is A2L sensors usually work on one of 2 methods. The first one is an IR sensor, right? Infrared. The travel of light in a known condition in the air is a known value. So what happens is, if we get A2O refrigerant that comes through, passes over the sensor, it's going to change the way the light reflects itself. It's going to slow down our beam, right? So usually that is one of the ways that you can detect if something is in the air. The second one is this one right here that I'm holding, which is actually an ultrasonic speaker. Once again, airspeed is a known value. So if we send ultrasonic frequency back and forth to a wall, we know that's a known value. But if something gets in between that sound wave, we will actually be able to know that something is there. That is usually how a lot of this stuff works, is like ultrasonic leak detectors or even like heated diodes. We're usually just measuring some sort of known condition, and then when you introduce something that's not known, it goes off. This will also cause these things to go off for weird things. You may have seen this before, especially in a mini split class, where people talk about spray foam. It's a big call that we get. People with new installs, A2Ls tripped, and they want a new sensor. But then we ask them, hey, do you use spray foam? And they go, oh yeah, a lot of it. It's like, let that thing air out. These units are pretty smart when diagnosing these. If you get a code, which you'll see here a little bit later, if you get a code that is actually a leak detected, getting you a new sensor will not solve that issue. Obviously, I know that sounds pretty obvious, but a lot of people think that that's the solution, is that if it's detecting a leak, a new sensor will just solve the problem. There's usually something it's detecting, right? There's something in the room, rather unfortunately it's cat urine, or it's spray foam, or if you use silicone on sealing something, or there's something that it's usually detecting. Now there's some locations that we can go over of where you'll expect to see these things. This is the wall mount unit. The wall mount unit has it off to the right side under the board, right next to the louver motor. See, we have our louver motor that's opening and closing our louvers. Pretty short cable that goes up to that board, and it's there in case obviously there's a leak there and it falls down into it. It's the high wall. This is gonna be the 4-way cassette, right? It's on the back side of the coil, right at the very bottom. I'm not gonna lie, it's kind of a pain to get to. You basically have to take all of this off, and it's up under that. And then replacing it, you would have to screw it back into that. But it's actually up behind this spot here on the 4-way. The next one is gonna be the slim sealing cassette, also known as the 1-way. It's gonna be up under this coil here. So if you take the cover off of the 1-way cassette, you'll see that it's actually up under that. It's pointing towards the coil, and the sensor is located facing that direction. This is going to be the universal floor-to-ceiling mount. With that being said, it should also be noted that there is such thing as a floor mount only with our units. I don't think I really said that earlier, and I'd like to clarify that. We get this question a lot, and I know a couple of people, probably who are watching, have asked this question a lot, where they say, can I mount this floor mount vertically? And I know that sounds silly to say that, but you can mount these vertically on the ceiling. They could sit on the ceiling and point basically at you. Right? Yep. Yeah, 18 and above, you can mount on the ceiling, or you can mount them on the floor. These, the 9 and the 12s, are floor mount only consoles. There is no option to do that. It's another thing that sales ask quite a bit, like Greg just asked about. Something we go over. But these are floor mount only. That one that you see back there, that's obviously providing cooling for this room, that's a universal floor to ceiling. Those are two separate numbers, or two separate units. But just be aware of that as we go through the that's the floor to ceiling mount. That's up under next to the blower. So for our unit, it would be like in the middle. Also something to note too, while we have this photo, is that the floor mounts, the universal floor mounts, actually have a dual shaft motor. It's kind of cool actually. The smaller sizes have one with 2 blower wheels with dual shafts that go to each. That unit has 2 dual shaft motors. It actually has 4 blower wheels inside of that unit. So as it gets bigger, obviously we have a bigger coil. So you'll actually see the motor once you pull down the filters and pull the filters out. This is gonna be just the floor mount console. The floor mount console is gonna have it up behind this. It's gonna be in the back here by the blower motor itself. It should be worth noting too that the floor mount console itself has like a little cover on the front where all of your sensors and all this stuff plug into, but there's also more connections behind it. So you can actually pull this out and then get access to this. This is gonna be the ducted multi-positional air handler, right? The one that you guys would think is a unitary unit. That's going to be up in the front. It's the same for the unitary, right? It's the same platform. We call it the G2 platform for this one. But it's going to be in the same spot, but it's going to be down in front right here in the corner. That's going to be the same for the A-coil. That's not going to change. It's still going to be down there on the side with the line set and stuff. It's going to be actually behind all of that. Now, EC1 and EC2, EC1 is the most common that we see, right? This means the refrigerant sensor is detecting a leak. It actually physically is detecting it, right? It's sensing the unit has more than 10 to 20% concentration, and it needs to enter leak protection. When it's a multi-zone unit, there's something very important to do. And we've had people that replace heads, replace everything, sensors, and they don't do this. When a leak is detected, the unit will go into leak protection mode, and you have to pull it out of leak detection mode. If you guys have called in with this code, you should be aware that the unit will not leave leak detection mode normally by itself. Some people try to reset it. Sometimes resetting it doesn't even help. You'll see in the next few slides that it'll go over the supercapacitor and different things like that. But basically, to get it out of leak detection mode and have it restart, you just hold down the outdoor button for 10 seconds. If it's got that code, it's not going to go away. If you've solved the problem, right? If you've aired it out over the weekend and you want to reset it, or you've put a fan in the window and exhausted the room, you need to reset it so it can redo it. EC3 and FHCC, these are refrigerant sensor errors. These are, it's not plugged into the right spot, or it's not plugged in at all. You have, let's say it's the mitigation board, right? You have the dip switch in the wrong position and it's looking for 2, or you have it plugged into the wrong spot. On mini splits, it's normally that it's unplugged. If it's plugged in and secure and the wires, it's not wet, there's not really a problem, there's not much you can do. It is a bad sensor. Having some sensors on hand, they're all pretty much the same, is a pretty good idea. Of course, board sensors, stuff like that. But that's usually what you're going to see when a sensor has an issue.
How sensitive are they to hairsprays and perfumes and that type of thing?
So they take a value of that. It's a good question. But they do take a value of a percentage base, but honestly, pretty sensitive. Even in my testing that I've done with that board and even with those air handlers, I mean, you shoot refrigerant at it for 2 seconds and it's shutting everything down, and you're gonna get locked out. And to be honest with you, I'd probably tell you honestly, probably every 2 or 3 days, we have that spray foam call. I mean, it happens a lot where the sensor, they don't like it. It's worth noting though that I don't have a problem with spray foam, right? I do highly, 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 highly recommend that you seal the hole that you make behind your unit. This is another thing that can cause your sensors to go crazy, right? Customer complains that it doesn't kick on when it's supposed to. What you don't know is you're dumping cold air into that room. And it's not really your unit's fault or your sensor's fault. There's a giant hole behind your wall. We see this in normal every day, right? When you have an Ecobee and the hole behind the Ecobee is that big and it's on an exterior wall to make things 1,000 times worse, right? We need to seal the hole behind it. We need to try and keep it on an interior wall, right? All of this stuff. But having a huge gaping hole that leads to outside, you can imagine that can cause massive problems. A better option that we've seen people do is like thumb gum or putty of some kind. That usually is a lot less off-gassy, right? There's a lot less VOCs when it comes to that stuff. Or what they'll do is they'll actually like fill it in with something, whether it's a rag or whether it's something, and then they'll spray foam outside to try to just keep it away from getting inside at all. That's fine too. Anything you can do to try to keep it away from it is fine. If you air out the room, it normally solves the problem. But they are very sensitive. If it's a house that's, cat urine sets it off a lot. Like there are things that will set it off. Smoking is another big one. And I understand customers aren't going to like that they can't smoke in their own house. But this is the way it is. This is what manufacturers were told to do. They don't want to do this. It's not something that anybody wants, but this is what's required for the A2L stuff.
Is that going to lock out the gas furnace too?
No. Well, yes, technically. If you're talking about the mitigation board, yes, it will. But as far as like the ball valve on something, technically no. But yes, in every situation when we have, it's actually a pretty good question. In every situation when we have mitigation, right, there's 3 things that every mitigation system needs to do, right, according to the government. The first one is we need to shut off the compressor. Whether that's killing the contactor, whether that's killing the call, whether that's killing something, compressor's got to go. You can't just keep dumping refrigerant into the home. The second one is, and it's to your point, we got to kill the gas furnace. As a matter of fact, we got to kill the electric furnace. We got to kill any sort of oil furnace, any sort of spark-making device, got to go bye-bye. The third thing you're going to do is I need that fan to turn on as high as I can do it. Now on a mini split, that's a lot easier, right? We can have that mini split go at full capacity. On your Goodman furnace, all I'm doing is sending a G call, right? So those things have to happen on pretty much every mitigation systems. Now there are some, if you don't have an electric furnace or you don't have a oil furnace or you don't have any sort of furnace, that you can use mitigation systems that just kill the heat pump, right? That exists out in the wild. But every requirement that I've seen personally, we need to kill all of it. So everything, all of it's got to go.
So what would you recommend in that situation where you like show up to somebody's house, you know, it's winter time, it's pretty cold outside, and like your gas furnace is locked out?
Well, I guess the real question is, why is it going off? That's going to be my first question, right? If the answer that you say is because you have a leak at the indoor coil, what I'd highly recommend in that case, isolate it. I can't legally tell you to bypass it. I'm not going to tell you to do that. But what I'm going to tell you to do is, if you got to get the customer heat, I would prefer if you would recover the refrigerant, pressurize it with nitrogen. Well, I'd actually prefer if you pull a vacuum, pressurize it with nitrogen, and shut your service valves. At the very least, I'd prefer if you'd pump it down and put some nitrogen in it. It's not really going to help because obviously your leak, unless your leak is in the outdoor unit, right? But at least you can buy yourself some time. If you just get the refrigerant away from it, it'll solve the problem.
Can you pump these units down?
That's a good question. Short answer, no. You can put them in cooling and try to close that valve. The problem isn't that can you pump them down. The problem is, what do you do once you have most of them pumped down, right? We have to recover what we can't pump down. So for example, if we pump it down and we leave, 15 PSI or 20 PSI, 30 PSI, what do we normally do, right? When we pump it down, we close all the valves, and then we fire the unit up, we release the charge, and then what? We charge by subcooling, right? I'm not doing that with that. I can't. We can't just charge it by subcooling, so we actually don't know that value. In that case, what I would actually recommend is that you reuse the refrigerant at the same house. It's perfectly legal. If you have filter dryers on your recovery machine, you can obviously use a good new recovery jug, pull a proper vacuum, get the moisture out of that jug, and then you can put it into that jug and then dry it and put it back in the system. You can recycle it and reuse it on the same home. I would prefer if you wouldn't do that with 454B. 454B is a little bit of a special situation. With 410A and R32, they're not high glide refrigerants, which means their blend is either one blend or it's a pretty isotropic blend. So it's 50-50, right? So when it comes to 410A, could it technically fractionate and leak at 2 different rates? It sort of could. It's kind of rare. You would have to have a leak and it would have to be off for a really long time for it to actually split molecularly, right? R32 can't do that, right? But 454B is an extremely high glide refrigerant. This is why you guys have probably seen on PT charts where you have bubble and dew point, basically, where it is technically a different pressure at a vapor than it is a liquid. This is why you'll see 2 different readings, right? Your gauges do this for you. There may be a situation where you could have a situation where it could have separated. So reusing the 454B is sort of risky because you really, really don't know. The upside I will tell you too with charging by weight is when it comes to mini splits, normally they don't hold as much as a 4-ton Goodman, right? A lot of these are single zones, 12Ks that hold 2 pounds. It's like not that big of a deal. But unfortunately, no, because you can't charge them that way, you don't really know what's left. Because is, 40 PSI half an ounce? I don't know. I mean, maybe. And then now, like I said, with 454B, I'm a little more leery to even say try to reuse it because you just don't know what's happened.
And technically, like, you could just take your stat, literally just run it to the furnace, right?
Yes.
completely, like take everything else off going outside.
If you have no refrigerant, then yes, legally you can technically not, you do not need an A2L system. If you've already,
Flammable is that?
not at all. If you've seen any videos, there's some really great content on that. Short answer, virtually not at all. It has to require a sustained flame. And what do I mean by that? I mean, if you hold this up and you have a lighter, right, and you shoot vapor refrigerant and you light it, it will catch on fire. That is true. However, if you shut the lighter off, it will shut off. It's not like propane or hairspray we'd use back in the day, and you could hold a lighter and then you don't need the lighter anymore. You can just shoot it forever, right? That's how propane stoves work. We light it once and the continuous motion of gas will require it. A2Ls don't require that. They require even more. That spark, flame, has to be there permanently. So worst case scenario, a lot of times if it is a spark creating device, you would just have the initial burst of it. But even if it was continuously leaking, it wouldn't keep shooting out like it would on like a gas line if you used a lighter, right? That could, no, especially if you have that, there are some situations where you're probably gonna have to do that.
It's like 12 in the morning.
Yeah, you're gonna have to do it. But as long as you, like I said, try to at least get the refrigerant out of it, pump it down, and then come back the next morning, look for the leak and see what's going on. If you get it out of there, then legally from your company standpoint, you could probably bypass it for the night and come back or whatever. From our standpoint, if you have no refrigerant in there, well, then you don't need protection, right? The other thing that will happen too, you can technically leave that protection in place if your leak was coming from there, then you now obviously fixed that issue. If it was coming from the home and you have to do it, that's a risk, of course, that the company would have to weigh to say, well, we got to do what we got to do, right? I'm not blind to knowing that those calls put you in a very precarious situation. But I think being transparent with your customer is the way to go and say like, hey, this is probably what we have to do. It's your unit. If this is what you want me to do, note it, document it, have them sign, and just make sure we're all in the clear. And that's probably the same that your company would say. But like I said, as far as like one of these exploding a home, it's going to be virtually impossible. Do not be scared of it. The only other keys that are really important is purging the nitrogen right. Let's try and get it out of there. A really weird thing that people bring up all the time is, why are we so concerned about this when we have gas furnaces in your living room? Methane or propane, like natural gas, is significantly more dangerous than this will ever be. Heck, this isn't even an A2. A2L is the beginning category. There's actually an A2, and then you get to A3s, right? That's propane. That's going to be R600, 290, and then R600 isobutane. That's when you're going to get to the A3s, and that's in your furnace all the time. And there is no mitigation system in that. We've all ran calls where you go to that and you have, a leaking union or whatever it is. There's no system to stop that from happening. It's all just part of obviously trying to be a little more conscious of it. America wasn't quite ready for R32 when 410A came out. The rest of the world's been on R32. They've just been doing it. This is why the patent doesn't exist for R32 anymore, but the patent does exist for 454B. Most manufacturers chose one or the other, right? This is why you're seeing a lot of both of those. You'll see Daikin, TCL, a couple of the other ones, Ox, they definitely chose that. But a lot of them chose 454B because they were concerned that the next requirement was going to be a little lower, 500 specifically. R32 is like a GWP of like, I think it's like 750 or something. And 454B has a GWP of like under 500. It's like 443 or something. So a lot of them chose that and they went with it. Obviously, as you guys know as technicians, we found out that R32 is much easier to access. It's much cheaper, significantly cheaper. A lot of that has to do with the patent and them not really being ready. But the mitigation kits, like I said, is to keep people safe, and adding them, unfortunately, does put you in a weird situation, especially like you said, if you have to get the heating, you don't really have a choice.
So is it good enough to know that, like, if I have a leaking, unit and the sensor isn't going off in the indoor, it's good enough to know that most likely the leak's not there?
Yes.
Okay.
Well, the other thing too that will happen with these, speaking of that, is that you'll get an EC1 code, but you'll also get a different code on all the other ones. So it will actually identify it for you. So if you have 3 6Ks, you'll have an EC1 at the one that's actually leaking. And then the other one, I can show you later, I don't remember exactly what it is, but you'll get leak detection on other multi-zone unit. It'll actually tell you that. It won't just say, hey, there is a leak, figure it out. It'll tell you which head is detecting it. And like I said, if this is the case, the only other thing you can do, right, is you can technically reset it, take that one off of the unit, right? Let's close it down, let's take it off. If this is really something you have to do, let's just get rid of it and we get them heat to the other locations, right? So that's another thing that you can try to do to get them heat tonight is just get rid of it, close it down, and get the refrigerant out of that loop. Obviously, you're going to have to come back and do a repair and weigh it out anyway, but doing what you have to do, it's really about the only thing you can do, right? This is what it actually detects. If it's over 10%, the buzzer will sound, the louvers will open, the fan will run at max speed, it'll display that error code, the outdoor unit, the compressor will stop, the fan will stop, and the electric ball valves will close. It'll close off if installed. Then it's going to obviously try to repeat itself. If it does not pass it, it goes into a hard lockout. If it does pass it, it will resume normal operation. We don't see a lot that it will actually pass it once it's done this twice. We see more often that it goes into the hard lockout. But that's exactly what it's doing when it displays that code the first time.
You got one over here, Jared.
Is there like a recovery mode that you have to put these in to make sure that everything's open, you're getting all of the refrigerant out, or do you just have to clear that?
No. Yeah, so there isn't, that's the other thing too. You guys have probably seen that some inverters do have that option, right? We get this comment a lot where like on the Carrier Infinity 5-stage, I can put it in charge mode and charge it by 17 degrees of subcooling. Unfortunately, the problem with the charge mode and a couple of the other things, even with unitary or mini splits, we don't have the ability to latch, right? We don't have the ability to lock it into a position. When you go through the Carrier Infinity stuff, you could lock it, right? I can lock it into 5 stages. I can lock it in the 5th stage and just take away all the other stages. You could force it to do that, but also the other thing with those units is they won't run past 100%. They just won't. They will never, they won't pass it. This is a really great question I actually asked them at AHR, where I'd asked them, you know, what's the highest value you've seen this frequency run at? You know, a normal frequency that we see these run at is somewhere normally between 40 and 70, right? That's usually pretty normal. They were telling me they were helping a guy in Alaska who was running a unit, and his unit was running at 167 frequency, which is insane. Please be aware, these units can technically run until they just mechanically rip themselves to shreds. In a lab, you can actually force them to run past their exceeding operating parameters, and you can shred the compressor itself. It'll just keep running. It'll keep ramping up until it goes there. So they don't actually have a fixed value at which this stops. So there's no baseline to be able to use to reference that. So there isn't a recovery mode. Like I said, you can probably put most of the refrigerant in there, and if you weighed out what you had and you really were trying to save that, you could try to put it in like cooling, drop the temperature as much as you can, lock out the liquid, right? The liquid that's going inside, and you could try to force it in there. You'd have to try to probably bypass the high pressure switch and then pray that the transducer doesn't catch it before you do. But at the end of the day, a lot of times you just have to, unfortunately, weigh it. There just isn't a way to force it to do that. And then when it stops and you have to restart it, well, now you're doing it again, right?
Is there a way to like force like the capacity to like hold like 100% test or no?
The short answer is no. The best way to do it is to make a call to do that, or to put it in forced cooling mode. Yes, you could technically go inside and put it in forced cooling. That's going to be the high capacity on all of the heads. That's about as close as you're going to get to that. Without getting too far in the weeds, there is technically a diagnostic tool that you can use. It's a little dangerous because, like I said, you can technically force that thing to run faster than it mechanically can, and you will explode it. Like, you can physically do that. So the tool can be a little bit dangerous. It'll also give you those parameters that the outdoor unit gives you, so that's why I don't talk about it too much. But in like a lab scenario, yes, you could technically force the outdoor unit to turn on. But what's going to happen is, you know, if you don't tell it to turn the fan on, or if you push it past its limit, You're not going to know until it becomes extremely dangerous. And it even tells you that when you get the tool that like, hey, if you push this past its point, it's on you. Like you're bypassing every safety that you have. It does all of this to protect not only you, but to protect your customers' investment. So we try not to force it unless you're asking it to run like that. And force cooling is going to be your best option for doing that. This is what that ball valve looks like on this unit, right? So on this side of the circuit, we have the EEVs, right? So you have electronic expansion valves that can close down these baby circuits. However, on this side, you're gonna notice there isn't any, right? So what do? We have all of them come back to one pipe that then goes through this electric ball valve. Once again, the valve basically was put on this side because if you'd have to put EEVs on all of them, an EEV is not big enough for the ball valve to basically close. So now it's a ball valve, and then like I said, you can reset it by pressing that button. Here's another picture of what it looks like in the multi-zone unit, kind of what it looks like, what it does. It just opens and closes inside of here to basically isolate the system so refrigerant doesn't continuously keep shooting if it is obviously a pretty big leak. Here is where I highlighted the error code that you're gonna see, right? And what you can do by pressing a long press on that button for 10 seconds, it'll shut off. The EEVs will start to move. The unit wouldn't start for 2.5 hours. We're receiving the leak code. So we have people where sometimes they want to reset it. The problem with just resetting it is they claim that the supercapacitor can hold charge for 2.5 hours. I've even had people who've left it off for a day, and for some reason, the unit still remembered, right, that there was a leak detected before, and it would not open. That button is your only way to open all of this stuff after you've done that. After you've figured out your problem and solved it, that is the only way to do it. It usually starts up, and then it will do its diagnostic check. It will run the compressors, it'll run the units, it'll check and see if you've actually fixed the issue. It will take a long time for these units to shut down in general, right? So when you're resetting these units, it's another thing too that is worth noting. Shutting them off for 30 seconds is not enough. A lot of time, what's really funny is when you reset this unit, it will actually give you a voltage too low error code before it dies. It'll tell you that for like 2 straight minutes. It's like, you'll see a code, it's, I don't know, it's like PC13 or something. And you'll see that it'll say AC voltage cutoff or AC voltage too low. And it just sits like that with no power. And you're like, wow, this is taking forever. But it's what you have to do if you're trying to actually reset these units for like dip switch changes or anything like that. So just be aware you may have to leave them off. And especially if you're doing any repair, especially on an inverter board, leave them off for 5 or 10 minutes. Go do something else. Go hang out in the AC, go do something. Do not ever touch an inverter board if you have not made sure that it is discharged. DC voltage is fast and it will kill you and it will mess you up. They're very dangerous. So make sure that the power is off on those. And like I said, you can press and hold that button, it's fine, and it'll go through its leak check. Does anybody have any other questions on that?
So if we're running it in like Hulk mode, is that efficiency still there? Like as far as like you're kind of running it at like full capacity as it can necessarily?
Yeah, so if you're saying like if all of them are calling? Yeah, so your capacity will be there and it'll exist as long as that performance chart is a compatible match. Your efficiency will be there no matter what. A lot of your efficiency is coming from the inverter side of the compressor, right? The inverter side of the fan motors, and even your DC fan motors inside. A lot of your efficiency comes with that. It's a pretty good question when you talk about efficiency, because as you guys have probably noticed and you've learned, inverters aren't going anywhere. They're not. Actually, as a matter of fact, maybe there'll be one day that that's all that will be out there. Efficiency is playing a massive role in that. Back in the day, we used to have 8-SEER units, right? 8-SEER train units and even lower, where we would just have PSC motors or, shaded pole motors or whatever it is. And efficiency is a major driver of where inverters are coming from, because that's about the only way that you can achieve a higher level of efficiency is if you convert the AC to DC. This is why you've probably, especially if you've not been in here not been in the trade for an extremely long time, But this is why you guys have probably never even seen a PSC blower motor or air handler blower motor. I mean, shoot, we haven't had those for 20 years. God, probably 15 years at least. I think in 2008, I think they were pretty much banned. Like every single air handler and everything is only ECM, but there was a time where they were PSC. But that's part of the efficiency push, right? The efficiency push is gonna push a lot of this to ECM 3-phase DC motors or some sort of DC modulating motor, whether that's a PWM or that's a serial communication blower motor, or whatever it is. A lot of that stuff is where it's actually coming from. But yes, if it's running at full capacity, of course it's gonna use a little more refrigerant, but it's rated for that and you still get that same.
How are these units, how are they gonna do when you split, like, take a coil and you put it off like a dinosaur oil furnace that only runs at, like, you know, a very same speed?
It's a really, really great question. So yes, so the problem that you're gonna run into with that, right, is that there's two different ratings when it comes to rating these things. And it's usually the outdoor unit by itself, right? So whether you pair it with a Goodman coil or you pair it with some other coil, it's not gonna matter. But usually you'll have that, and then you'll have it rated with a coil, and then you'll have it AHRI rated with an actual gas furnace, right? So unless it's rated with all of those, nobody knows what the rating is gonna be. Another great example of this is we get this question a lot, mostly on unitary, right? Where they go, I know that this unit's pre-charged for 25 feet, but my coil's a half size bigger. Do I have to add for the length of my coil? Somebody asked me that the other day, and I thought, no. But what I do think is this. If it's not AHRI matched and it's not actually a confirmed compatible thing, then you're doing the best that you can with the information that you have, right? So if you did have to go up a half ton or whatever, you're not really gonna know if that is actually gonna be pre-charged for this. A lot of these things, especially with mini splits, you have to worry about it a lot less with mini splits because there's a lot less room for play, right? A great example of mini splits is you cannot put another mini split head on this. We get this a lot where people will even try to do ACiQ to ACiQ. And I know I've said this before, but it's worth noting you can't always do that. I got a call from one of my buddies actually locally, and he called me and said, hey, I have an ACiQ 12 W-HH-MD, and it's on a ACiQ K12. I'm done talking. We don't need to. Why? Because K denotes it's a TCL unit. You have a TCL unit matched with a Medea unit. He's like, yeah, it won't turn on. I'm like, yeah, because that unit is looking for 240 volts on 1 and 2. He's like, yeah, I figured that out, but I switched it with 2 and 3, but it won't communicate. I'm like, yeah, because they don't speak the same language, right? So as we go through this, you're gonna have a lot less leeway, unfortunately, but you're also gonna have more procedures that you can follow that will actually be 100% correct, right? Because they've tested it with their 6K, with their 12K, with their 24K, the parameters that you're getting as far as like adding charge and doing things like that will always be something that you can follow to a T. Where it gets sort of messy and where you're getting at is when you try to stick one of these on an oil furnace. The problem is I can't tell you if that would work amazing. I will tell you this, it's worth noting for people, I don't think it was talked about in the unitary class, but it's worth noting that these coils are not rated for oil furnaces. Specifically the drain pan. They are UL rated up to like, I think it's like 250 degrees. Obviously there's not a lot of oil furnaces that can output that sort of temperature, but obviously putting transition in between them and trying to keep it kind of away from it is what it's rated, but they don't have high temperature drain pans that are manufactured that you can just slap on there like you can a Goodman. So the problem that you're gonna get is, yes, what you've already established is not only are we going to lower our efficiency dramatically, we're gonna really kill it because we don't have a variable speed motor. If at the very least we had like a 2-stage motor, we could hold quite a bit of our efficiency, but it is gonna tank when you just have a single speed motor and you're trying to put this on like an oil furnace.
So ultimately, probably not the best idea.
No, no, I would not recommend it. It's not that it can't work, it's just that it's kind of silly. What's up, Zach?
Got a question.
Yeah, what's up?
Penny at ACiQ asked,
Oh my God.
can you explain why you can't put the floor mounts for the ceiling on an angle like a vaulted ceiling?
Yes, the way that the coils are pitched is going to be your problem. The coils sit in there at like an angle, right? And the pan itself catches it, whether you're sitting like this or whether you're sitting like that. And there is no pan that actually connects it in the middle. So if you have it at an angle, it's almost straight down. So the water basically just falls straight out instead of actually rolling down the coil or rolling up to the other side. So that's really going to be your main problem with that, is that you could do it. You just better have something there to catch the water. It's probably going to be your problem. If you're cool with water leaking out of your unit onto your floor, heck, you can do whatever you want, right? But that's really going to be the problem, is that the angle of the coil is going to kill you there.
So were you guys just talking about not putting this on a dual fuel system? Is that what you guys?
No. He was just asking, like, how does it kill your efficiency if you put it on in like an oil furnace? And the answer is yes. I mean, it definitely does, right? If we're not going to at least put it on like a 2-stage furnace, we are going to lose a significant amount of efficiency.
Have you heard anything about updates on like some oils, ratings of oils furnaces? Is that in the future plans or no?
Probably not.
So that's where somewhere like a conventional system would probably need to stay.
It probably would be a better choice to do that. The other thing too is, it's not that you can't, and people have, right? I don't really have like a major problem with it, but it's kind of, the best way I describe it is like you're putting a Ferrari engine in your Honda Civic. It's not that you can't do it. You could, but is the engine worth more than the car? Probably. And the whole point, right? The whole point that we're trying to get to is that at the end of the day, and this is even way more true with oil, if you put in a hyperheat air handler, especially with the Platinum hyperheat, I mean, it can heat almost 80%, even down to -22. Like, I don't even need your oil anymore. You should, not that I love this world, right, where we're all converting to heat pumps. I'm not saying that's really the solution. I love gas furnaces, especially natural gas. But my plan is to try to not use any oil. I kind of want to get rid of it, especially oil. Propane, you want to keep it, that's totally fine, I get that. 2-stage furnace, that's going to be your best course for efficiency's sake. But with oil furnaces, I tell my buddy this, he's got one, and I'm like, if you got this, right, hyperheat unit, honestly, I kind of think you should switch an air handler. I don't even care if you put electric heat in it. I don't really care. But he'll have the full variable capacity matched with that air handler, and he probably can just abandon oil altogether. He could even have electric heat backup. Obviously, you'd have to run circuits. But in his case, too, what's interesting about those two units that were talked about in the unitary class is they're 120 volt compatible. So it'll even fit where his electricity already is, which is a pretty cool thing that you can do. And the hope would be, of course, that if you're using a hyperheat, you can get 100% performance down past -0, and you can get a majority of your performance at -22. And of course here, correct. That's just performance based upon that. And there are charts that go over all of that stuff. That's performance charts for that stuff. And like I said, I'm not going to sit here and say that fossil fuels are the devil or that they should all be banned. But oil itself is a dying. I know some people don't want to let go of it, and that's fine. A lot of people also prefer the heat of oil and prefer the heat of that. And if that's the case, don't get a hyperheat outdoor unit, right? If they're going to prefer to use that, then just set it to a normal lockout of 40 degrees and get a normal non-hyperheat. You're going to save a little bit of money there, and they're going to want that anyway. So it's more for those more mild days, right? But when it gets really cold, most people switch to their gas furnace. I don't know how many calls that I've ran for natural gas furnaces where they don't even use the heat pump. They don't even use it. Emergency every time. Boom, emergency. I don't care. Especially when you're on natural gas, it's like, can't argue with you there. But propane, a little bit different, right? And then oil, like I said, a lot of those people are stuck on that. And it's not that you can't do it, it's just that I personally would not. I would probably, if it was, my relative, my mom or something, I would probably try to say, you know what, it probably is gonna work better for you and definitely save you money in the long run if you get off of oil.
No farmers love that.
I know they do, I know.
Talking about electric heat pump extreme heat, would that control know if you switch the breaker off for the heat kit?
No,
So you can just leave that off and
Yeah.
like if your customer was energy conscious, you can just flip it off and turn it on.
as long as you're not feeding the unit by that breaker, right? As far as the high side of the circuit, and I honestly, as far as the low side too, even the high voltage side of that circuit is not monitored. Even the low side of that circuit's not monitored. Super, super, super basic when it comes to those heat kits. The one right there sitting on top of that unit, right? You have your high voltage that comes off your breaker, and then you have your low voltage that comes off the plug, right? And it's not being monitored at all, so it just sends 24 volts to a relay, and then that relay closes for your high voltage side, right? With that being said, it's not watching that. It doesn't care. Like, it doesn't know.
Is there a setting on that board to tell that unit what heat kit it has, or does it even matter?
It doesn't really matter. So the only time it kind of matters is if you want to unbind them. And what I mean by that is you have two options normally, right? So if you have a 5K or a 10K, you only have two wires. We have our W1 and we have our common. Those are your two wires that you get. If you have a 10K or 20, you do get a third wire that introduces W2. Now in the unit, they are bound together. You can unbind them with a dip switch, but if you're using a communicating stat, you're gonna have to change some dip switches. There is like time delays that you can add, like 90 minutes or 30 minutes or whatever it is, whether you wanna ramp up one or two. However, almost all of them is just gonna be default running the whole heat kit when it's being called for, right? If it notices that it's been running for a specific amount of time, that's a dip switch, or let's just say Ecobee, because it's gonna be easier to explain. Whatever that is gonna call for W1 and W2 is then when it'll turn on and off. But it doesn't necessarily care. And that's something too where some people will plug it in and they'll only power that little terminal block down at the bottom, and then they'll say they have a bad heat kit. But it's like, we're not even getting high voltage to that top side. Like, we gotta make sure we have it on both, because this isn't gonna know. You're never, ever, ever, it doesn't care. There's no monitoring that it's doing. That's why you can put whatever size you want. You don't have to tell it what size or if it's even there. It'll try to run it. We've even seen, this is a question you guys have probably seen online, where people want to use water coils, right? So we're talking boilers. It's a big question that we get is, can I put a boiler coil on top of this unit? Short answer is, as long as it's not majorly restrictive, you can. What we would prefer, of course, just like any other boiler system, we prefer if you would use a 24 volt stat, you know, bring that to your 24 volt stat on RH, right? Use a common, complete the circuit that way. However, if you technically wanted to use that unit and use a communicating stat, right? You could technically steal the 24 volt wire that comes on a heat kit. You could put that to a relay, right? So you could go 24 volts out from the board, and you could technically steal a relay off the heat kit as well, and you could go into the coil. And then on the other side, you could have your R and you could have your W to your boiler, and it's normally open, right? So what happens is when that air handler, TLO4, KJR, or whatever, calls for electric heat, it's gonna close like a thermostat to your boiler, and it's gonna activate them both. And as long as you don't have like a bypass system that's gonna trick it, technically it's not gonna overheat the coil, it's not gonna trick any of the sensors, it'll just add extra heat just like it was the electric heat, right? You can technically do that, it's not that you can't, it's just that a lot of, like I said, air handler situations, you don't have access to natural gas. It's the whole reason you have an air handler, right? Normally you don't have access to that, but there are some, especially in New York and some of our influencers, where they deal with, they have it, but the state is incentivizing them to switch to air handlers, right? So they still have electric backup heat and they want to utilize it. But that's how you would do it with that. Just steal the 24 volts.
Price of natural gas, I'm thinking about ripping my furnace out and putting one of those bad boys in there, man.
What a lot of people are doing. You know, to be honest with you, at least what I've seen 10, 20 years ago, or 10, 15 years ago, that was definitely the case. Natural gas is super, super, super expensive compared to electric, but a lot of people's electric bills have been going crazy. Now, will that be better? Yeah, for sure. There's no doubt about that. Yeah, they're pretty close. And, you know, it's really just kind of what you think and what you run into. But yeah, there is a lot of people, honestly, like I said, that are switching from their gas furnace and throwing one of those in and then just adding electric heat if they need it later. But we've seen most people, especially with those, they don't even do electric heat. They just don't. Just don't even, don't even worry about it.
I mean, I know here, we have like 3 or 4 weeks of extreme cold in the winter, and then after that, it goes back to normal. I mean,
That's the other thing too, and you guys know this as text, but people may not who are watching this later. But you have to remember that when we're doing load calculations or when we're designing system, we don't design it for -22. At least here we don't, right? Maybe you do if you're in the northern part of Canada or something, but like you said, it's less than 3% of our entire year is above 100 degrees and below -10. Usually you're somewhere around designing it, you know, for somewhere around 5 degrees and somewhere around 90-ish degrees. That's normal for us here. But those that are outside of that realm, you need to make sure that you don't oversize the unit. Oversizing the unit is one of the worst things you could ever do, even with mini splits in general. If you ever are on the fence, undersize it. Especially with these, because they'll kind of push past the 3 tons of capacity. And you'll see that they will try. They'll give it their best shot. Your Goodman's not.
If you look at the product specs or the just how it's performing, a lot
Yeah.
of times you'll see where it's well above its rated BTU capacity.
Now this is where that 100% I'm totally on board with. Where I get really, really nervous is that everybody in every single situation, and no offense, Greg, but every salesman love to try to sell it for its ability to ramp down, right? There's a minimum amount of capacity it has to have to run, but putting in an oversized unit may guarantee that it'll ramp down, but it doesn't guarantee it's gonna actually not have humidity issues, right? We're not gonna have short cycle run times. Saying that you could put a 5-ton in every house and it'll just ramp down is not true, especially with these air handlers. I wanna point out that something when you start looking at the service manuals for those air handlers, they have constant airflow motors, right? And what do I mean by that? It's very different from constant torque motors that you guys are used to, looking at a Goodman chart, taking a static pressure and looking at how much CFM you're pushing according to that static pressure, right? These units, specifically that one, if you're anywhere between 0.1 and, or 0.1 and 0.8, you're gonna get the same amount of airflow. It does not matter. That's why you don't set airflow on these. On that one, you can go up to 1 inches of static, which is pretty crazy. But if you're between there, it doesn't matter if you're at 0.2 or you're at 1. You're gonna get the same amount of air because they are constant airflow motors. It's the highest category you can get to, right? This is why you don't set airflow. But where it gets messy is when you put that unit, a 5-ton, on 2 tons of ductwork, it's gonna try and push 5 tons of airflow, and your static is gonna go through the roof. That is where it's gonna struggle. Now, will it eventually settle down and maintain temperature? It probably can, but it can only ramp down so low, right? When you grossly oversize them and just bank on them ramping down, that's not always, actually, that's never the solution, right? So sizing them properly and making sure you do proper load calcs and make sure you look at the ductwork is extremely important when it comes to those unitary units. We're gonna take a break and then, no. The PAH has its own.
The PEAH.
Yep.
Is for the PAH area, and there's like an EAH for the standard.
Correct. Now, to be fair, you're sort of on the mark with that. The that heat kit technically can go in any Gen 2. Now, what do I mean by that? The technically EAHC series, it fits in almost everything. It'll fit in the multi-zone, multi-positional ducted air handler. So our mini split, you can put that in there. It'll fit in the other line that a couple of other companies sell, like Infinity Living, right? So the DIY stuff, it'll fit in those. It'll also fit into the 410A versions. Now, technically that's a B series heat kit, but it's literally the same platform. You can take that C series, stick it in that 410A unit. It's the same thing. Now, where it gets squirrely is the PEAH, what he was just saying. That technically comes in 2 separate pieces. It's underneath that unit over there. It comes in 2 separate pieces and actually gets mounted. And then the second breaker is actually on the right-hand side. You'll see the knockouts are in a different spot. But that one has its own. That's the only one you have to be kind of aware of. But for the most part, that one can fit pretty much all of them.
I have a question. This might be stupid, but what's the easiest way to access that board that's on the bottom of the top panel?
Tough question. Short answer, taking off the front panel, like this right here. This is gonna be, oops. this is going to be pretty much the way to do it. So when I talk somebody through getting it, right, step one, let's take the top off. Step two, this piece normally comes off. Now that's not universal for every manufacturer, right? But Medea does it, which is really, really, really nice. The other thing that Medea does that's really, really, really cool is they usually actually have connectors on connectors, right? So for example, if this board was face down and I was trying to measure this motor, right, instead of unplugging it, you normally have a connector to where you actually don't have to get all the way up into the board. You can normally unplug it here and then take your readings. So you don't physically have to get to the board. Yes, this board would be face down, but if you look at all of this stuff that I'm gonna pull out here, you have connectors. Really important to note, this is where, once again, and I'll get to it a little bit in a minute or once we come back, but reading your wiring diagrams is really, really important, and they've gotten substantially better when it comes to the 454B products. What's really, really cool is these wiring diagrams, you're gonna see a couple of things that have been added, and it's the voltages that you should really kind of be seeing, right? It'll also tell you the colors. So you can see yellow is our high and low pressure, red and red, high and low. So you can usually trace it to find out even what the color is, right? And then if you go down to this, you'll see red. Okay, red is our high, or yellow is our high, and red is our low. You can see it here. Usually you have a connector that you don't actually have to get access to the board. You can just measure it here, or you back probe it, or do whatever you need to do. I do like that they've added a lot of these connectors, so you don't physically have to get to the board. We're just gonna use this chart, and we're gonna follow it that way. It's a really, really cool tip. The other thing you'll see when you look at this board is, like I said, the outputs for what the voltages should be, right? This is where you can get a lot of data of, like, for example, if you forgot, it's like, hey man, what is that reversing valve? Is it a 24 volt valve? You can look here and you'll see, oh no, there it is. It's 230 volt valve. So I should see 230 volt. Yeah. Yeah, check it out. Now it won't, now be aware of the DC voltages. A lot of it is control voltages, right? And what I mean by that is when I went over thermistors, right? We talk about what thermistors are doing. Thermistors are just your meter, right? They just send a constant voltage. They measure the resistance using Ohm's law, right? And they give you a value. And the board is doing the same thing. So you should see 5 volts coming from there, and it'll be coming back, right? But it's very rare that you're gonna have the 5 volts missing, and that's why your thermistor's not working, right? If it is, you might have a connection issue. That's the only time I would use the DC voltages, is basically what I'm getting at. They're usually for reference, not for like...
Right, it's mostly just to make sure the board's doing.
Yeah, exactly. Like I said, usually for like reversing valves, right? We're gonna try to confirm that. Or what you should expect on the other side of like a thermistor. As far as like the compressor and the fan motor and stuff like that, I would not recommend using it for that. However, it will give you an idea of what to expect. What's up, Zach?
We got another question. Adrian asks, so is a half-ton oversized technically okay?
Yeah, it's not grossly oversized. It probably will have the least amount of problems. Yeah. Doing a proper load calc and getting as close to it as possible, right? If you're really that concerned about it and you're using a normal standard unit that's in our lineup, right? Like a PSC motor and stuff like that, then maybe going, a half a ton or, quarter ton up is probably gonna be your best option. But with these units specifically is maybe what they're asking about, I would probably not do that. I would probably go slightly below, because I know, especially looking at the capacity chart, I'm probably gonna get a little extra out of it.
So better to undersize than oversize?
Yeah, when it comes to inverters, 100%. Now, like I said, not grossly undersized and grossly oversized,
Like a
but
half ton.
yeah, if I'm stuck in between it, right, which is probably more to that question, if I'm stuck in between it, I'm gonna choose slightly lower. And to full transparency, I don't do a ton of the low calc stuff. Of course, by the time it gets to me, the only time I'm doing it is to verify if this is even in the right spot, right? But if I'm stuck in between it, if it's an inverter, I'm gonna go slightly under, just because I know I have a little bit more play to go up. And also, like you said, you gotta make sure you have that extra half tonnage of ductwork. I'd rather it run for an extended amount of time and get a little bit better dehumidification and maybe ramp up a little bit more than trying to throw this unit in a situation that it's going to short cycle and we're going to have humidity problems or noise complaints or anything like that. Those are going to be a lot harder to overcome than if you just undersize it from the start. That's a good question.
That's real cool how they tell you the output, what.
Yeah, you like that?
Yeah.
You ever notice that? Most people didn't notice that. It is kind of interesting. Important. If you guys haven't looked at a lot of these charts, these things are really cool. And like I said, 454B really stepped up their game by adding those outputs. Most people don't even know. They've never even seen it. That comes on top of that. This is like you could pop open your unit and you could see this. This stuff comes already on top of it. Not every unit comes with the wiring diagram, but every service manual does. So you can always go to the service manual, and I'll show you that when we get towards the circuit board stuff. You can go into the service manual and look at the diagrams, and I'll show you how to find it and search it and things like that.
How much longer until you're done?
30, 45 minutes,
Okay.
maybe.
Are you taking a break real quick?
Yeah, we're on a break right now.
Hey, if you guys want to come grab food.
What's up, Thomas? notice that it always has the yellow wire too, because that's our S communication terminal. But on normal unitary units, you don't communicate like a mini split, right? So they give you that in case you are using that heat kit on the multi-positional ducted air handler. However, you do not need it, and just leave it.
I almost messed up because I almost put my like a power to it, because on that board it will say L1 and then L2, but then neutral kind of falls under that middle one. So
Correct.
I was like, wait a minute, is this L2 or is that? And I was like, no, wait a minute.
Yeah, it gets a little weird too because they're multi-compatible with 120 volts, with 120 volts and 240. But you'll see actually, as you do more mini splits, you'll actually see that if you like look at their boards, they usually always say L and N. You know, when it comes to overseas, a lot of these units just run on 240 volts, but it's one hot leg and one neutral, and that's 240 for them. But it's not the same for us, right?
Seems to be we're the odd country out.
Yeah, yeah. The only thing I will say that we're not the odd country out is for Fahrenheit and Celsius. It's like, I think that doesn't really translate super well. Like, it makes sense for water, right? But for air, I don't know, you know. Maybe that's just the American side of me that's a little biased, but.
I was thrown off too with the remote that came with that. You know, I guess they all come with the remote.
Correct.
Because the customer saw it and then grabbed it. I was like, no, just leave that in with the unit. We're going to use it.
That's for the
We got to come
installer.
for troubleshooting.
That's so you can turn on the fan right away.
And I was like, just let it be. Don't be messing with it.
Yeah, I agree. That's another thing that's kind of weird. So that point check function, you can technically do it with the remote on those indoor units. If you try to do the point check function with those, you can't do it, but you can put it in query mode, which is actually on the slides here in a minute. And you can pull data off of that indoor board and see what like your sensors on the indoor unit is doing. That's a good reason for the remote. Another reason for the remote is to adjust some of the settings, right? If you get a customer that really just thinks the unit is too loud and you absolutely have to take the fan speed down, you have to do it with the remote.
You can't do it with a communicating controller.
You can do it with the communicating controller, but if you have a 24 volt SAT, you cannot. You can do it in that, you can't do it with the wired controller, you can do it with the TLO4, but you can't do it with that. So you have to go in the engineering settings and then in the service manual, and then you have to adjust it there. There's a couple of other things you can adjust with it, but for the most part, we tell people the same thing, just don't mess with it. Like, you don't really need it unless we need you to need it, right? But in the service manual, it does go over that side of it.
So probably the only way to put this on a dual fuel system, this one here, would be to use the 24 volt.
No, if you buy the coil, you can do 2-wire indoor to outdoor. The coil comes with the board.
ACiQ low.
What? Yeah. Yep. The mitigation board that comes with the coil, you can do S1 and S2 out of it. You still have to do 24 volts to your furnace.
Okay.
Actually, that's a solid question. We just finished this. Greg hasn't even seen this yet. I'll show you something cool while you wait for everybody.
Diagram.
No. Much cooler. Much cooler.
Easier to read than the board.
Yeah, what, my diagram that I drew? Check this out, Greg.
Oh, is that the new dual fuel one?
You got it.
Oh man, guys, you've been wanting that.
We actually just finished this.
We're gonna get that today.
Yeah, we just finished this. So this is the quick start guide that we made for that board. So it was gone over a little bit more in the unitary class, but of course we didn't have this. But that board has the ability to communicate with your outdoor unit via S1, S2. So technically, for example, if you wanted to put this on a customer who has an AC only, and they only have 2-wire, Y and C, you could put the 2-wire on S1, S2 and give them full options for a heat pump outside without running a new wire.
Could you still use the smart thermostat and go to HA and HB, and that board will control the furnace?
You got it.
Nice.
That's what that is right there, right in the middle, that board. That's the coil that connects to the board. It's 2-wire connected to the outdoor unit, and it's 2-wire connected to that TLO4 sitting in that little case right there. So this allows you to use the standalone coil, but still use the communicating thermostat and communicate with the outdoor unit. Or,
This board comes on that coil?
yes sir, for free, yep. It comes with that coil. So this allows you, you can even use an ecobee if you want. These are the input sides right here. slightly less efficiency. That's really about it, right? You'd have to set up more of the dip switches, like I said, for staging it and doing things like that. But you just lose a little bit of efficiency because, once again, we don't have a TS to reference. We just generate our TS from T1, so that's where we're losing a little bit of efficiency, but it's not much. It's worth noting, though, for you guys who are doing this, I called out quite a few things in this. The first one, you guys heard me mention it earlier, is that don't plug it into the red plug or the left plug, because that could change, right? This could be blue someday, but plug it into this one on the right. We do not have a coil that requires 2 sensors. However, this board can accommodate 2 sensors. If you plug it into the wrong spot, you're gonna get a sensor error and you're gonna think you got a bad board or a bad sensor. The second thing I'd like to point out is that this dip switch has to stay off. If you turn that on, it's gonna look for 2 sensors, which you do not have 2 sensors. So you're gonna get another sensor error. It also, I wanna point out that it comes with some stuff, right? It comes with the T2 sensor that comes pre-mounted on the coil. It comes with the return air temperature sensor, which you mount, the T1 extension cord, and the A2L sensor, which is mounted on the factory. That little case, or that little bag that I dumped out that you guys saw when I pulled out the thermistors, right here.
And you say that all comes with that coil?
You got it. All of this comes with the coil. So this comes pre-mounted on the coil. This comes pre-mounted on the coil. You mount this in the return. And this is an extension cord for this in case you're kind of far away from your board. You don't need this if you don't want it, whatever, I don't care, don't use it. The last thing I'd like to note is this board is gonna do something kind of weird that you guys aren't really gonna like, but I've tested it and it for surely works. I'll show you once we get to the last diagram. But basically, you have outputs for your common and outputs for your R. I'll get to it when I get there. It's only 2 pages. The first page is gonna go over 2-wire to 2-wire installation, right? So we're gonna do our communicating thermostat HAHB to here. We're gonna plug in our sensors, right? Here, here, here. And then if you wanna use extension cord, you can. On our single stage gas furnace, we're gonna put R and C here. And then on the right side, right here, is our outputs. Once again, we call it out down here. We have our outputs to the furnace, OW2, OW1, OG, out Y2, out Y1. So we have our outputs there. Don't need to do any dip switch changes on this board. It's set up for communicating. Now we're gonna go to the second page here, and we have 7-wire to 2-wire, right? So we can use our TLO4 in 24-volt mode or an Ecobee or something. We can put it on the input side of this board. And then we're gonna put our outputs to the furnace out this way. We're gonna turn on the SW1-1 dip switch. This is the same for our air handlers. That will tell it you're looking for a 24-volt stat, but you're gonna communicate outside with 2-wire. Now the last thing, which is what I was just referencing that I told you I'd get back to, is right here, okay? If you use 24 volts outside, I don't care if you're using a contactor, I don't care if you're using a 24-volt board, I don't care if you're using our board. R and C has to leave out of this block. Okay, right here. This block comes off. Has to leave out of this block. We did call it out at the beginning of the quick start guide. So if you got a contactor, just bring common here. If you have a heat pump board, like let's say it's a Rheem outdoor heat pump, you're gonna bring your R and C out to the outdoor condenser. Now this is where things are gonna get a little weird and you guys are gonna probably have a question. What you should is you're gonna notice that I have this contactor going to my thermostat. I did not do that on accident. I did it on purpose. But you guys might say, well, Jared, that's the craziest thing I've ever heard in my life. What happens when there's a leak? Your thermostat is still sending 24 volts to that Y terminal. You're gonna run my outdoor unit in the middle of a leak? That sounds pretty dangerous. And the answer is, no, I'm not. And you're gonna say, how's that possible? And I'm gonna say that there's a relay on OC that opens. This is designed like this on purpose. Normally, what we're taught in every A2L training you've ever been taught is you can always bring it to the furnace. It's not that you can't bring it to the furnace, but there are some situations where the furnace blower outputs are a little weird. Bringing them here and making sure that you're using the proper outputs is how you actually need to do this. And then the dip switch changes that you need to do for full 24 volts, and then for S1 outside, S1 or S1-2 outside to put our unit in 24 volts. If you're using a contactor, obviously you don't have to do that. It's just worth noting that. And what you'll see here is that we have, like I said, OY1, OY2. I do have them connected properly. OY1, we don't have the 2 stages, we just have the single stage furnace.
Why would you use 24 volts though when you have that communication necessity?
What do you mean? Oh, why would you? Well, there are some situations where, are you saying for like a thermostat or for the outdoor unit?
Yeah, just like when you have that communication available to you and that board comes with it, I mean.
Why'd you do it? We have a lot of people who don't want to do that. We have a lot of people who want to see 24 volts leave, and they'll even put our outdoor unit in 24 volt mode and hook it up that way. Even if they have this option, they will still do it because they just prefer it. There are some situations where, for example, let's say it's like old cloth wiring, right? And it will cause communication issues if it's not in good standing. And in some situations, if it's around a lot of electrical interference, you may need to run shielded, but it maybe isn't possible for them, right? Or, for example, if they don't have our outdoor unit, then they don't have a choice. You have to go full 24 volts. Yeah, with this setup, yeah, it's pretty odd. I ask that question a lot, even to our techs, when they're trying to like diagnose it and they're searching through and they're doing all of this stuff. And I'm like, why aren't you doing 2-wire outside? Because if you do 2-wire, the other thing that it does really well is defrost. If you don't do that, you're gonna have to hook up D to your input, and this unit's gonna go into defrost and send a call to your indoor unit. If you put it 2-wire, what this will do is that it'll actually kill your blower when it goes into defrost. It's not gonna turn on your furnace. It'll just let your coil just get cold. Stops everything, it'll wait until it goes through defrost, then it'll turn everything else back on.
What's the W turn it out there for?
What do you mean?
On the outdoor unit?
That's a funny question. I actually went over this yesterday. Not to get too far in the weeds, the short answer is it's a heat pump call. So you're probably thinking, why would I need a W call when I have a B? What do you mean? The longer answer is this. When the unit was first designed, they did not have a B call. They didn't have an O call. They didn't have anything. They had W and Y. Those are your only 2 options. No heat kit, no nothing. So the only situation where you would be using W is if you had a conventional thermostat that doesn't have heat pump and you had no other backup source of heat. So you had no heat kit and you had no gas furnace or anything. So regular W is a heat pump call. For example,
4-wire static.
yes, exactly. Yeah, well, 2-wire, like dial thermostat, right? Yeah, or it's technically 3-wire because you have, R, Y, and W. Those dial old school thermostats with the clickers, that's the only situation where you would use that. And I'd highly recommend not doing that because most techs are not going to be familiar with that, and trying to troubleshoot that's kind of hard. The only other time I have people use it is if I'm talking to somebody who doesn't have a jumper and I'm like, hey, let's get the outdoor unit to run in heat pump mode. Let's go ahead and use 24 volts to W and we'll use our common outside. So I only have 2 wires, so that's how I'm going to utilize it. Yes, I could technically just hook up common to common, Y, and then jump it to B outside. I could do that too, but I try to tell people, and you'll see I called it out in here as well, not to use W.
I think some of the early reams, they had a W terminal coming back for, energizing your furnace.
Yeah, and in this case, on this unit, we use D for that purpose. So D is going to be our call back. Also, I'd like to note, now that we're just on this topic, this board does not produce 24 volts. Don't look for it there. That's not how this works. As a matter of fact, I don't even need R on a straight AC. I don't even need it. Keep it, put it in the trash, doesn't matter. I don't need it. I need common, and I need Y1, or I need common, and I need Y2. That's it. On a heat pump, R is an input to this board to be able to send back on the defrost signal to come back to your heat kit or gas furnace or whatever it is. You're not going to find 24 volts. This unit does not have a transformer. It's not making 24 volts. This goes back to my point when I told you that the reversing valves don't run on 24 volts. There's not 24 volts on this unit. You give it 24 volts so it could send it back to your heat kit if you want. However, this is why we have just communicating. Imagine if we took away its ability to have 24 volts. Or where the heck is it going to get it? It doesn't have a transformer. So there is no 24 volts. So we got to use something else, right? D works like that. L is an alarm code There are some thermostats that have an L. So like, for example, if your outdoor unit has a fault, it'll send like a 24 volt and it'll be like, alarm, please check your unit or something like that. There's not a lot of American thermostats that can do that, so we don't really talk about it much. And then like we were just talking about, W is technically a heat pump call. I just recommend you don't do that, especially when most of us are familiar with B and O. So that's kind of how that works there.
Now, when you do have like a non-communicating system and you're trying to wire it like that, and you landed on S1 and S2, that will like blow the board, right?
Correct. I'll be honest with you too. Another major problem. I mean, that is a major problem on AC onlys, especially the 410A, because on 454B we moved it, right? So it's down here now. On 410A, they put them up here. They also didn't have these little doors. There's a lot of problems with that, but I will be honest with you, especially about this board. If you're gonna do a lot of these boards, I'd highly recommend that you make sure that that S1, S2 cable is in amazing, good condition and not at all nicked. What we've been seeing is people are blowing these boards a lot. And why is the question, right? First thing you could do to blow the board, you just set it. If they put 24 volts up there just for fun. I don't know what it is with these people and putting 24 volts on S1, S2, but it happens a lot. The other thing that we see is that if there's any ground source, any sort of damage to this wire that touches any sort of ground source, whether you pull the wire and you have this energized, or there's some sort of grounding or conductors or touching any sort of damage to these wires, will blow this chip up here. It's a really long story, but I've done some deep dives into it. And it's just something you need to be aware of. So if you have any damage to that cable, you've got to replace it or go full 24 volts. I know you don't want to, but it's not going to work if you just keep replacing the board and you have damage to that wire and you can't see it, or it runs through some sort of junction box. The DC communication is too sensitive and the board will blow. It just cannot do it. So those are situations where you may have to go. Yes. Yes, bad, yes, and it happens a lot. And also, I will note, it normally blows your A2L sensor too. Because this chip is a voltage reduction chip. I obviously didn't design it, but it takes that in, but it does share 5 volts with this to the thermistors and to the leak detection sensor. So you can damage a lot of stuff by having bad wiring. Bad wiring is the leading cause for people blowing this board. And as you guys have known, if you've done any A2L stuff, they're very sensitive. They're just up to something, right? But that's another thing to be aware of with that. Go to our PowerPoint here.
So I know we talked about zoning earlier.
Yeah.
You can still do the communicating, but so no communicating if you have a zone system.
Correct. You could technically, well, the problem is that you're going to have to send that Y1 and Y2. You probably could communicate with 2-wire outside, but you cannot use the, like we don't have a zone panel to do HA/HB to a zone panel and communicate. So you're at the very least going to have to use 24 volt inputs and then send that outside because you're going to have to use Y1 and Y2. But no, you can't, we don't have a communicating controller for that.
If you had this setup though, couldn't you run your outputs from that board to your zone panel, and your zone panel would take over to at least operate the zone panel?
Well, yeah, as long as you use a 24 volt stat, yes. And then you could do 2-wire outside, that's fine. But what's gonna have to happen is you're gonna have to bring everything to the zone panel, and then your output is gonna be to the air handler, right? So our inputs will be the thermostat, the 2 thermostats, and then our output will just go straight to the air handler. So when your thermostat's calling and it's like, okay, only one's calling, I'm gonna send a Y1 call. That will tell my air handler to go Y1. So yes, you're kind of right, but you have to do that because there's no, like he wanted to use a 2-wire thermostats. And there's no way, because we don't have that interface like the Carrier Infinity does and stuff like that. This is really worth pointing out. Like I said, there's really not that much left. I know it's supposed to end relatively soon. But this is really important. One of the biggest changes that they added was a little more protection to these units. And one of those protections are barrel fuses. Okay, there are barrel fuses on the single zone units that are 3.5 amps, or 3.1 amps. And then the multi-zone units use a 15 amp barrel fuse. Now, why do I bring this up? And this is a really good example, right? This is that diagram you guys were kind of looking at with that. This is on a multi-zone unit. We get this call a lot, okay? A lot, where customers will, unfortunately, do their install and their heads won't turn on, or they'll be getting ELO1, or something will be happening. And they'll check and they don't have 240 volts over here. And without looking at anything, they condemn the outdoor board. My outdoor board is not sending voltage to my indoor heads. Bad outdoor board. Give me another one right now. But what they don't understand is if you actually look at the diagram, this board is not in charge of high voltage to your heads. Actually, has nothing to do with high voltage to your heads. The only thing that the heads are connected to, the board, is number 3. It's very important to understand that. It's a major change that changed everything. Now, what is in charge of sending high voltage to your heads? Well, a jumper. Boop. And it's jumpered. Boop. And it's jumpered. They're literally just jumpers that exist on the back of the board.
So then your indoor's powered all the time and just waits for 3 to tell it.
There you go. So we have this constant. So if you check and you got 240 here and you only have 0, or you have, let's say, 122 to round on both legs, well, you've got a blown fuse, big dog. There's not much we can do here. You have a blown fuse. This could be for a couple of reasons. Normally what we see this happening by is if you guys have done quite a few installs, you may have noticed that sometimes the head units might have a test wire still attached to them. You just get rid of it. It's like a little jumper basically where they power the head on, make sure it works. Sometimes they forget to pull that jumper off. Well, we've had a couple of people who leave that on and it's physically touching behind their wall and it just continues blowing fuses and they don't know why. So then we get a photo of their wiring and we're like, what is the extra black and red wire? And they're like, I don't know, it's like a jumper that's laying behind my wall. And it's like, get rid of that, dude. What is that? Like, there are reasons that these fuses are blowing. You can buy them, they're not like crazy expensive. But it's worth noting that those are there. With that being said, I have a picture of what they look like that I sent myself a long time ago. That way you guys can see kind of an example of what they look like in the field. But they unscrew. It's in here somewhere. Yep, here it is. DM, zone. Here we go. Boop. And what you'll see here is we have our voltage going in, and then a little terminal block and our voltage going out. And then if you look, it's literally just a bunch of jumpers. I'm not kidding. Literally jump, boom, jump again, boom, jump again, boom, jump again, boom. That's all it is, right? It's very similar to the barrel fuses that you guys have probably seen in the air handler, right? They're screw-on terminals, so they unscrew and the fuse comes out. It's very, very, very similar, and it's behind that panel. Just wanted you to know like where it is. You'll see I pointed out here too in this photo. Boop. It's got a little 15 amps, 600 volts. It'll tell you all that stuff. You can also take the fuse out and Google it. It'll tell you the size. But this is something worth noting because it's a question that we get quite a bit. Another question that we get that I'm gonna run through really, really fast is Wi-Fi, right? There's some confusion around Wi-Fi. What's up, Zach?
Real quick before you jump into Wi-Fi, we had a question before we broke for lunch.
Okay.
HVAC guy asked, oversized may be okay. What about undersizing for systems that use multiple heads? Thinking not all zones will need peak performance at the same time.
Yeah, that's probably fine, honestly. If you're using multiple zones for one centralized location, then yeah, you'll be, more than likely, it's not gonna call for all of them at the same time. The problem though that you could get into, and it's obviously worth noting about that bypass, right? So when you're in heating, you're still gonna bypass that 10% bleed through. So that is where you could get into a little bit of trouble, but as long as you don't grossly do it in the same area, you should be okay. Would I prefer if you would just run, 1-2 ton? I mean, if you need more than that, then yeah, you're gonna have to run multiple in one space. But yeah, that's probably fine then, because like you said, they're not all gonna call for the full capacity all of the time. It's really the ones in the room that are grossly oversized that I'm really worried about. It's worth noting on Wi-Fi, and like I said, I don't want to spend a massive amount of time on this, but all of our head units, including every manufacturer we have, come with Wi-Fi built in or given to you, okay? So when it comes to the single zone R32 units, those come pre-built in. It's not a dongle. It's actually like a little bracket that sits right in the front, and it has Wi-Fi. Smart Life Smart Home is the app you use for TCL. The multi-zone units, they actually do have a dongle, but it comes plugged in from the factory. That's that one right there. And they use the AC Freedom app. And then when we get to our flagship products, which is obviously what we're going over today, Medea products, all of the wall mounts come with dongles in a little box. If you haven't seen that yet, they look like little USB sticks. Grab one. They come in the accessories bag. They're not going to come pre-plugged in. If you haven't seen one before, they look like this. Like a literal USB stick. They plug into that photo you just saw. Right here. This little spot right here.
Backside of the door.
Yes, this is the, yeah, that's technically that photo right there. That unit with it laying right there, that's underneath the top side of the air handler. So open the door and look up, and that's where you're gonna see it. On the floor mount console, it's literally to the right of that little panel I told you about. When you open the filter, you'll see it. It's inside of there, it's a dongle. The universal floor to ceilings, this is important because Greg has asked this question a million times.
One screw and you gotta push it side and slide in the top to it.
Yep, it's got one screw, you slide it over to the left, and then you can get it out. You can use the ACiQ app for all of these, just like you would use the ACiQ app for the TLO4 or the KJR. Anything by my Medea uses that. To the next one, the floor mounts. So the technical floor mounts, just the straight floor mounts, right? These come with a dongle right here. And they plug in just like the wall mounts. It's on the right. You can't miss it. It literally is underneath the wiring guide. These floor to ceiling mounts do not come with Wi-Fi. They just don't. There's no option. You can, however, put Wi-Fi in them. We've had a couple of contractors, and even I've done it myself, where you can put a KJR inside of them. You can plug in a KJR on 4-wire on the 410A, or if you're using the 454B, they have HAHB. You can run 2-wire and plug in a KJR. That's that white thermostat that you guys have seen. Stick it in there, mount it to it, boom, bada boom, you got Wi-Fi. Concealed ducts. Concealed ducts are the only unit technically that doesn't use a remote, right? Because you can't see it. So those come with thermostats for free on our 410A. They came with a really, really basic thermostat. A lot of people like to call it the calculator thermostat. It's not a KJR 120N or X or anything. It's the L version. On the 454B, we chose to try to buy everything with Wi-Fi if it was an option. The concealed duct, what they did was they give us KJR 120Ns for free with the concealed duct because we bought it with Wi-Fi. So instead of using the 4-wire plug like you guys might be familiar with the 410A concealed ducts with the little Molex plug, you actually run just 2-wire from the concealed duct HAHB down to your KJR and then connect your KJR to Wi-Fi, and boom, you got Wi-Fi. The slim ceiling cassettes, these have the dongle. That's where this actually came from. This dongle plugs into the grill. There's a panel that comes down behind the grill, and it plugs into the grill, which then, of course, communicates with the actual thing once you connect it all. The 4-ways do not. Some of them might, but they don't. But they do have the option to run HAHB as well. Let me look this up really fast. Wi-Fi. Dongle. Confirm that. Because they actually might actually, let me double check.
Are you on Wi-Fi on the 4-ways?
Yeah. That's what I'm talking about, yes. Okay, they actually do, and I believe the 4-ways actually come with the dongle, but that dongle comes with an attachment. I remember that now. It comes with an attachment that plugs into the board via a 4-wire plug. So they do, but I believe it plugs into the grill as well. And then we already went over the floor mount or the wall mounts. All the wall mounts do, you just got to plug in the dongle. I didn't want to forget that, so I'm glad I remembered that. So when it comes to troubleshooting, okay, this is pretty much the end of what I have here. most common failures on mini splits, right? Flares. It's not even close. Like I'm saying, it's not even remotely close to the most common failure is bad flares. Okay. What constitutes a bad flare, right? Damage to the flare face, not using the proper tools to make a flare. Nobody's saying you got to go out and buy that HVAC tool. But there are good things that you can do to actually make a good flare, right? Step one, don't forget to put your nut on. If you're anything like me, you're gonna have to forget to put your nut on 3 times and then cut off your perfectly good flare. And then for some reason do it again. I don't know why I like to do that, but something fun, I must think it's awesome. The second thing I would recommend is if you're going to use manual tools, right? There's a couple of things to keep in mind when you're using manual tools. The first thing you should have is probably a stopper of some kind to give you the depth of the flare, right? You wanna make sure that something is stopping it, pushing up against it. The second thing you wanna make sure, I can't really get this off, but the second thing you wanna make sure is that your cone is eccentric. It's like, it's off at an angle, right? There's an offset for the cone. I'm not saying that you can't make a flare right with the stuff you get from tech school where it just pushes in the flare. You can, but the odds that you're gonna break your flare, you're gonna have weird marks on it are much higher than if you have an offset cone that's spinning and widening it instead of widening it all at one time. That will help tremendously to make a good flare. The second thing you should get is your tool should have a clutch, okay? What do I mean by that? And I mean, it should basically allow you to spin it for the rest of its life. And it should click. This will prevent you from over flaring it. This clutch is right inside of here, and it will prevent me from deforming this flare or flattening it to my heart's content. Now, technically on a regular flaring block, you can just smash it into a million pieces if you want to. This will stop me. This will stop at a specific depth and make sure that it actually is the proper dimensions and thickness for the flare. The parts that make a good flare is the flare face itself with the actual service valve. Okay, your threads are not making your flare. Your flare sealing surface is the surface of this, right? And the surface of your actual flare itself. These are the 2 mating surfaces that actually seal up against the flare. Okay, so with that being said, there is one thing that people do that also kind of rubs me the wrong way, is using stick reamers. If you don't know what a stick reamer is, it's basically like a little handheld reamer that spins around, right? And it's not that you can't do that. You should always deburr your copper anytime you're prepping your copper and stuff like that. But using a stick reamer, a lot of times what you'll see is you're gonna damage your flare face before you even start flaring. It's gonna push up against that copper and you're gonna scratch the inside of that copper with your reamer. So what's the solution to that? It's using one of these circular tools. So what you'll do is you'll make your cut, right? Then on this side of the cone, you have basically one that pushes in. You'll deburr it, right? And then we'll deburr the outside with the other side of the cone. Deburr them both, look inside, make sure there's no bits in there. If we can, of course, at a down angle, get anything out. If not, we'll have to use nitrogen. And then what you're gonna do is flare it, and then you're gonna check it with something called a flaring block. That's what's in this picture right here. A flaring block allows you to make sure that, number one, your flare is big enough, but it'll also give you dimensions. Halfway through the flaring block, it will stop you, right? If your flare is the right size, it'll stop you about halfway through. If it's too small, it'll go all the way through. If it's too big, it won't let you in. But about halfway through, it'll stop. That way you know that you didn't over torque it, right? That you didn't under torque it. Once you do that, obviously making sure it fits on your nut, that's obviously super important. And then making sure your surface is made. Now, I get this question a lot, is how do we feel about flare sealing surfaces? I'll tell you, I've never really had a lot of luck with like, the little gaskets and stuff like that people use. The only thing that I've worked that works for me that we totally are okay with is Nylog. But understand this, Nylog does not go on your threads. I understand it's a thread sealant, but in this case, you actually don't want to do that. Nylog needs to go on the face of this unit, of the actual seal. Try to help seal the actual surfaces that are connecting. Now, why don't I want Nylog on the threads? Because it changes your torque value. It also could help maybe back that flare nut out through vibration. You don't want that. You need the torque value to be exact, right? And you need to be able to trust that there's nothing that's interfering with that. No cross thread, right? No pipe dope, no Teflon tape or anything like that. If you do that, I'm not saying it will just completely kill your ability, but these will all reduce the ability for the flare to seal. So a little bit of nylon, that's fine. Just try to keep it off the flares or off the threads.
You went to an old school refrigeration class that built your bullshit.
Yeah. Unfortunately, we've done a lot of learning, at least for us.
Because we used to use refrigeration oil.
You can do that too.
On the threads, behind, between the nut and the back.
The nut, none of it, yeah.
Because you didn't want any of that to be false friction.
Yeah, that's another thing too. And to be fair, like I said, everybody's going to kind of do their own thing, and you may see that. If you guys don't have nylon, he brought up a really good point that I didn't bring up, is that using a little refrigeration oil is fine. That's what can you do a dry flare? Sure, absolutely. You can totally do a dry flare. You can just dry this and stick it on there and torque it down to spec, and we should be okay. But if you like to have a little bit of something, if you got a little bit of oil, a little bit of, yeah, it's a great.
That's why you can't find leaks in evaporator coils sometimes, because the oil seal.
Yep. Oil's a really, like even vacuum oil or any sort of like POE oil or something that you put on the surface. Also, a little side tip, you can also put it on the actual part of your tool that's actually pushing up against it. This will help reduce friction. It'll help, obviously, make sure that you don't deform the flare or shred the copper if it's super, super thin. You can put a little bit on that while it's mating, and it'll... Exactly. It's all the same. It's all about as thin as it can get. 1/4-inch flares, going to be the hardest ones you ever do. It's really, really tough. But these are ways that you can actually try to help that. I never really have put any on the back side. It's a really good question. Yeah, and it would push up against it. Another thing too is like over torquing it. You definitely have a pretty good chance of actually like crushing the flare. We see this a lot. There's one sitting on my desk actually where over torqued it and it just crushed the flare. I mean, it made it so thin that you could almost pull it out.
I have a torque guy that talks about lubricated torque versus dry torque.
Yeah. Yeah, that's what's nice is like all of those readings were really done with a dry fitting. And like I said, you could still do it. It's just things that will help you. And obviously you'll have to try and see what works for you. But those are what we have found that works for a lot of our contractors. The second thing is the most common failures, PCB units, right? Everybody loves to blame the circuit board, and listen, I'm with you, right? It definitely can be an issue. And obviously when it's an issue, it's a big issue because a lot of this stuff, we're not bypassing boards and we're just telling it to start, right? That's our biggest hurdle with any mini splitter inverter is they're not universal and I can't just tell it, hey, run just to get me cooling right now. I will tell you this, almost all boards a lot of them are misdiagnosed, right? Obviously if there's physical damage, they're pretty easy to diagnose. But once again, a lot of people blame boards for what they think it should be doing versus what it's actually doing, right? A great example was that EEV one that I told you about earlier where he was going to blame the board and the EEV even though we weren't feeding it enough refrigerant, right? So some issues that could cause this, right, is surges or even lightning strikes, corrosion, loose connections. The outdoor unit, I mentioned it earlier, it can technically be too dirty and it can cause the heat exchanger on the board itself to overheat and sometimes it can't save it, right? Adding surge protection is the #1 thing you can do to prevent this, but the gold standard is voltage monitoring and surge protection. The voltage monitoring is really, really common when you get into commercial, like 3-phase applications, right? But they do make them for residential applications, and having that is a really, really great way to prevent that. We have a contractor named by Mini Splits USA. We were talking to them while we were at IBS this year. And they use this product, right? Love this product, it's a great product, made by Dytech. And up to 40 amps, you can use it for 120 volts or 240. And they put this as a requirement on every job they sell. They're the person who I was telling you makes their techs only do one head at a time. I can't remember what it was. I think it was 2 years ago ordered a total of 20 boards from us for warranty. Currently, they're at 1 in a year and a half. They said it is a requirement. It is not an option. The customer has to get it. It is part of our package.
I used my first one last.
Did you? Okay. Well, I put it in my video when I did an install. It's an incredible thing. Now, will this protect?
Yeah.
Voltage monitor and surge protector built in, both. Now, it's going to monitor both legs, right, for over voltage, under voltage. The other cool thing about surge protectors and voltage monitors is usually they have some insurance, right? A lot of you guys aren't owners, but the people who are owners, you can file warranty claims with them to reimburse you for the board that it didn't protect. Like I said, minimum surge protectors are required, but anytime there's an IPM, and what I mean by that is an intelligent power module on a circuit board, voltage monitoring, I can't stress it enough. It's just so important. If you've already had one board failure, you really need to consider it. That thing's about 199 bucks. I wouldn't say it's expensive, but it's not cheap, right? But if trying to keep your customers happy and preventing callbacks and all that stuff is important, if you've already lost one board, you really should consider it. Putting it on standard will help as well, right?
Is that cool guard just disconnecting the high voltage unit?
It'll do both. So it monitors both legs. If one of the legs go under,
To the unit when it gets an under or over?
you got it. And it has onboard diagnostics here where it'll even tell you why. So if the customer says, hey, my mini split won't turn on, and they walk outside and they send you a picture and it's flashing red here and it's green over here, it means this is the leg that's having the problem.
Solid state, there's no contactors.
Nope. All solid state. Once you take this panel off, and like he said, he's done one, you just have the input side, the line side, then you have the load side, then you have your ground, and that's it. There's really actually, what's cool about the Cool Guard is there's nothing to set. It'll auto do the 120 volts. Huh? Correct. It's rated for outdoor unit. It has a seal inside of it.
Yeah, I think the only setting was if you wanted to, if it faults out, if you wanted to kick on after 30 seconds or after 3 minutes.
There you go. That's the only setting you can change on them.
Getting one through Supply House, they had a mechanical contactor. and
Yep.
It works good.
Yeah, I have one maybe in there. One of the boxes, I have one from ICM Controls that has the mechanical contactor. It has the voltage phase monitor. I had to get one. I couldn't really use this one here because that unit, of course, is more than 40 amps, so I had to get one with that, but it had to have a 60 amp mechanical contactor. But that's better than nothing, but this thing is really cool, and it's installer friendly. It's a disconnect, right? I mean, you could see installers actually doing it right, you know?
They have the holes already there.
Yeah, they have the holes already there for you. Amazing product. I can't say enough about them.
Function as a disconnect. Though.
It does not. No, you have no option to like shut it off.
I would use it actually functions as a
It's inside the disconnect. That's pretty sweet. Yeah, that would be awesome if you had the ability to do that. But this would technically, I'd prefer it if you put it after the disconnect because then you have the ability to shut the power down if you need to swap it or something. If it takes a hit, it has a service required light to basically tell you that something's wrong with it. But amazing product. I can't speak enough about that. I wish more people would do it. It would save people a lot of grief. The other common failure, the misters, right? We went over this already. There are some situations where they can BOL. There are some situations where the wires rub and they will short themselves out, break the wire, stretching, environment damage. What's up, Zach?
Penny from ACiQ.
Oh my God.
I just got off the phone with an influencer who installed a KJR thermostat, and his customer does not like having the fan run constantly. He's removing it and replacing it with TL104. Is that normal? It's on an HPD AHD system. Would the same thing happen on a mini split with a KJR?
That's a really great question. It's one of the biggest questions that we get. So let's start off with the mini split question. Mini splits by design will run the fan all the time. That is just the way it works. If you ever put a window unit in, that's going to be the same thing. It's for a couple of reasons. But yes, it is very common for them to want to do that. Now, the real question is, what's the biggest reason why they do that? And the answer to that is I need air to pass over my sensor to know what the return air temperature is. Now, could I turn my fan off and just use whatever? Yeah, right? Ecobee does it. 24 volts do it. Everybody does it. It's not that you can't. It's just that if I'm trying to precision control my speed and I'm trying to use that return air temperature sensor, I want to push air across it so I really know the perfect time to turn it on and to turn it off. The KJRs for that AHB, they have the ability to go into, I've mentioned it before, follow me mode, so he didn't actually have to rip the KJR off of it. He could put it in follow me mode, and what that will do is use the temperature sensor inside the KJR instead of using the return air temperature sensor. So after a couple cycles, it will shut the blower off. The TL04 has the blower controls as well. But for mini splits, the only way to shut the blowers off is through the engineering mode, and we do not recommend doing that because it can definitely change some things, especially on the high walls. What we've seen is when people do that, what actually happens is, especially with like heating, the 10% bleed through, it'll actually trick that return air temperature sensor because temperature is going to rise. And what it'll actually cause is that unit never to come on. So if your problem was overheating, now it's just never going to come on because it thinks it's always that hot. Once again, you're going to have to go through the diagnostic process of figuring out why the temperature thinks it's so high and go through all of that. So it's just easier and more efficient to keep the blower on all the time. But it is something that people do ask about a lot. Temperature thermistors, we kind of talked about. The problem that you're going to run into with that is they can be hard to detect because they won't always tell you that they're bad, right? Just like I said, is the thermistor bad, or did you turn the fan off and now you're dumping all that heat on top of your return air temperature sensor, right? That's something you're gonna have to figure out. But we went over those. Killing compressors due to overcharging when you try to charge them like a standard system, or you braze on mini splits. Got to get crucified here, obviously, especially by the old school mini split trainers, is brazing with nitrogen is the single most important thing you can do with this. I know that these units, like the unitary units, come with braze to flare adapters, but they have a lot of screens, right? There's a lot of filters, there's a lot of mesh, right? All of that stuff ends up turning into oxide inside of your pipe and getting thrown through your unit. You can do it yourself if you want. If you want to go back to your shop and braze with nitrogen and braze without it, it's true, it will end up inside your unit. It's just a matter of time until it kills it, right? Those are non-condensables that will not be compressed, right? That will cause issues. Why people ask, why do mini splits only come with flares? It's so you don't braze. It's the answer. They don't want you brazing. They don't want it. They don't need it. They don't need it as a failure point. So a lot of manufacturers reluctantly have added, as you guys have seen, the braze to flare adapters, but a lot of them prefer if you just don't. If it was up to me, I would do what I did with that PAH unit, and I would bring the line set to it and flare the line set straight to the unit. I don't need the braze to flare adapters. I have the line set. I'll just bring the line set to my unit and then just flare my line set straight to it. I don't need to braze on any of that. I brought it straight to the unit, right? Now, I understand that that's not always possible. So if we're going to do that, we want to try to obviously make sure we're brazing with nitrogen. We're not trying to contaminate anything, right? We talked about the compressor stuff a little bit already, right? On the rotary compressor style, have our accumulator, and then we have our rotary, its side that has our discharge and our suction and our vane that spins around. I briefly told you that if you get liquid inside of here, you will crack this, you will cause issues inside of that, and then you'll just have bypass that goes through there. That's why you don't get, that's why your discharge and your suction end up becoming closer to the same. Your compression ratio drops. You're physically damaging this forever. The other thing that you're doing when you don't braze with nitrogen is you're building up Cooper's oxide inside the compressor. It's getting on the shaft, it's getting on the plate, it's getting on anything. I don't remember what the statistic is. Copeland put it out, and they said, I couldn't believe, I think it was 87% of all compressor failures that they asked for back were due to bad install. Whether it was moisture that got into the system due to a terrible vacuum that ended up killing the unit, or it was liquid floodback, or it was some sort of plating or some sort of issue that was actually not a warranty issue. It was caused by bad install practices. Pulling a vacuum, brazing nitrogen are things that are only going to hurt you and your customer. A lot of manufacturers, as you know, have been trying to deny warranties, right, on compressors, especially if there's a lot. Normally, we don't go that far into it unless for some reason there's 10 of them coming out of you for some strange reason. Then there may be a situation where we start looking into why this is happening. But we try to obviously support you the best we can. But doing yourself a favor and protecting your equipment and your customers, installing it right is the most important day of the system's life, and it's not even close. And I know a lot of us are service techs, so we don't have that luxury, but when you do repairs, doing them right to prevent a callback is all that matters, right? This is one of the final slides. This is all the error codes that you can get, right? Some of them are just operating codes like defrost or forced cooling. This is some of the stuff that you guys have seen before. Pressure sensor issues, refrigerant leak detection. The second one, let's see if I can find it. There it is. ECC1 is what I was looking for with you guys when I was saying that the other unit will tell you if it's detecting a leak on a multi-zone unit. So you're gonna see ECC1 if another head has detected a leak, but this one's not running because of that. So it'll lead you in the right direction to figuring out what's wrong. So this just goes through that. This is one of the last things is parameter checking. I told you guys how to check the parameter on the outdoor unit. You can also do this on a mini split head unit, right? If you have a single zone and it maybe doesn't have that board with the little display and all that stuff, you can use the parameter check function on the remote by holding down these buttons, and you can go through and see what all those readings are, even on a single zone unit that may not have that display button. The single zone units, obviously, usually you get your data and all of your information from your indoor unit, but you can also do that. And this is the same thing as the compressor stop thing that I told you about. If for some reason your customer did turn it off after your last code, you can look up and see why it stopped. That's it. Does anybody have any outlandish questions or anything like that?
Can we get that electronic or?
Yeah. Yeah. Reach out to Nicole. I'm going to send it to her. I'm actually sending it to him too. You guys can have the PowerPoint.
Are you on the slide deck?
Yeah.
Yeah.
You can have it. Yeah.
Because when you print it,
You can't even read it. I know. That's why. Well, Nicole wanted to print this one, and I was like, this one's like 111 slides. Yeah, that's fine. I have that too. I can send them both.
Will she have that wiring diagram of like the?
Yes, I can add that one. The only thing I have in there right now, I can tell you what it is. So I have in there right now is, let me get that wiring diagram. They just finished that one, so they were releasing it to everybody. In the presentation right now, I have the PowerPoint, the multi-zone, single zone cell sheets, right? And then the compatibility chart. Those are the things inside of there. But I can also put the one from last time in there too.
And that wiring diagram.
Yeah, I just put the wiring diagram in there, and let me pull up the one that you were just looking at. It should say Alexia on it. Yeah, okay, this is the old one. I will add that one in there too. Yep.
Do you guys plan on making it so you can check the pressures on the board anytime soon?
Probably not.
Because sometimes, like, I know for, like, when we check Bosch's, like, one way we can tell if the pressure transducer is good or not is matching those with our gauges.
Yeah, that's pretty common on like even like the York 20-SEER inverters where they have transducers on both sides. That would probably require them to put them on both sides, which the only issue is, I mean, obviously changing cost and all of that stuff. To my knowledge, it's not required for operation, so I doubt they would change that. And especially on mini splits, man, I've been pounding the drum to try to get that. Heck, honestly, even on unitary units, I've been pounding the drum to even get a true suction line. There's the kind of, I don't know, it's kind of going somewhere, I guess is the best way to put it. I try to mention it, like it would be awesome, right? Because we get this question a lot is like, how do you charge this unit in the winter if I don't have a low side?
We were going to braze them in.
Yeah.
If we ever open it, like, we're just going to start brazing them.
Yeah.
They're gonna tell you recover it and weigh it in.
Yeah. Well, what's weird is, yes. Okay. So your answer, what they actually say is, run it in cooling, big dog. That's what they say. And it's like, okay, I mean, I guess you're kind of right. Like, kind of.
Units not running.
Yeah, they won't do that. And it's like, okay, I guess you're kind of right. So they kind of are. You could put up a tent, put it in cooling, and I mean, you would heat your tent too, so it's not the end of the world. Like,
Do they have a amount of time that you need to have power energized to that crankcase heater before you turn them on in the winter?
no, they would prefer, right, if the unit has been outside for that long, that trying to leave that on for at least an hour, but there are some situations where you can't, and I haven't seen any like major failures due to that.
You get them wired in, turn power on, and
Yeah.
sit there while we're finished.
It's usually what people do. So we don't see a ton of issues with like the flood back. I don't know if that's the difference between like the rotary and the scroll side of it. But the only ones we've seen that required that was the package units. Package units for sure. I mean, they're mostly outside anyway, but they recommend that you get power to it. While with that being said too, we do get some people that call in and are like, hey, I'm blowing nitrogen through the unit and I think the EEV is not opening. The answer to that is power the indoor unit. Power the indoor unit for like 60 seconds and shut it down. It's gonna move it open if that's stuck there for you. Getting power to the unit is one of the first things you should try to do. Get power to it, get it moving. Like he said, even getting the crankcase on, getting all of that stuff before you go to fire it up is a really, really good idea. And it's a really good standard practice to get used to. So at least trying to get power to it and letting it kind of warm up, right? What's up, Zach?
All right, we got a couple questions. So first, Adrian asks, why aren't these and many other brand systems not required to have a liquid line filter dryer?
Awesome. Great question. Briefly went over that a little bit earlier. And the answer to that is because there's no dedicated liquid line. That's the first thing, right? On mini splits, but then you may ask a follow-up. Well, why can't I do it on this unit? There is a dedicated liquid line on the unitary units. And the short answer is, you kind of can. It's not against the law. No one's gonna arrest you for it or be that upset. But what they don't want to do is they don't want it to become a restricted point during low ambient operation. Even a slight restriction, especially during low operation, will cause a pressure drop and it may turn into a metering device. The other thing that matters when it comes to these units is the oil that they're using. You guys that have been installing Carriers, Goodmans, and all of that, they use POE oil. This uses PVE oil. It's a little less hydroscopic, so it's not as aggressive when it comes to that purpose. All mini splits are trying to switch to that. Almost all of them have. And then, like I said, for mini splits, there is no spot where liquid is prevalent. The liquid line is prevalent enough for you to put a filter dryer. So that's the answer for mini splits.
Awesome. Got a couple more for you.
Okay.
You have another question that says, where can I get the PowerPoints and diagrams?
Ask Nicole. So reach out to your dealer coordinator or your salesperson, I guess, and then have them reach out to Nicole. I will send them to her. I'll send it to the sales guy, well, to some of the salespeople. I'm sure she can get them out to them too. But if they want this presentation today, that's fine. I'll send it out to them today.
So another point too, going back to powering up those heads, you should do that before you do a vacuum too.
Probably should. Somebody asked me this the other day. Somebody had a really good question. They weren't working on our unit, but they were like, hey, he has an EEV mate. If you guys don't know what that is, it's a device that you plug in an EEV to and you can open and close it manually, right? And he was like, do I have to open all these EEVs before I pull a vacuum? And the short answer is no. And you may say, Jared, that's the craziest thing I've ever heard of. You just told me that it could be a problem. But there's one thing to understand about mini splits. And it's this diagram that I stole and put in here and credited. Right, and it's right here. What is going to happen if you don't open this EEV? Well, we're going to pull a vacuum through this, which is going to go inside, and pull a vacuum to this, right? If all of the service valves are open, then I'm also going to pull a vacuum through the unit all the way up to the EEV head. So technically, once again, because we only have one EEV, I'm pulling from both sides if the system is fully open. If not, it's trapped through there, and it won't be in the way for that. Because if it is fully closed, right, and I opened up these valves and I've released a refrigerant in there, it technically will just have refrigerant from here all the way up to here. It will keep that refrigerant in there. If not, let's say if one of them are open, it's gonna let that refrigerant pass up through and go out whatever head, all of them, and then I'll pull a vacuum through all of them up to my second port. So no matter what, at the end of the day, technically don't have to open them. Where you would run into a problem is if for some reason you had a ball valve that was also shut and all the EEVs were shut. Well, now you're not even pulling a vacuum through the outdoor unit at all. But on like a standard system, it doesn't have the ball valves. One side of your system is open to the rest of the circuit anyway. Because once again, you have one side that's short, that's the EEV, and then you have the other side that's wide open going inside and coming back. So you're technically okay both ways. What's up, Zach?
Got another question for you. Adrian asks, could the voltage monitor and surge protector be added
Short answer,
We don't sell them.
not really a me thing. It's been brought up. Here's what I was told about this, and this is more of a sales thing. What I was told is surge protection already is a pretty small subsection of our sales and our add-ons. The concern is, of course, if they included voltage monitoring, that if, let's say, a fourth of people bought just surge protection, well, an eighth or maybe a 16th would buy voltage monitoring. We currently don't offer them on the portal. I know that's something that sales has been talking about. But yes, it definitely could be added as an accessory that you could physically add. We do have a supplier for it right now. But your salesman should try to push the director of sales to get that added to the portal. And it could be something that could be offered. That's not unrealistic. But as far as the package that you're probably referring to is the Universal Mini Split installation kit. That one already comes with a surge protector. Yep, the little baby surge protector. Could they build one with a voltage monitor? Maybe. The problem is going to be like, how are they going to add it? You know, who are they going to use?
We've discussed additional installation kit options.
Yes.
Some guys would rather have a 1/2 inch width, not a 3/4.
There you go.
Or a DES30 or a fusel disconnect versus not. So there's obviously so many configurations that you can go with different codes.
Yes.
It's been discussed. We haven't obviously gotten super far down the road, but I have like certain contractors that are like, I have to use a fusible. Like I'm required them up here. And
Sure.
it's unlike that we're only sending non-fused and stuff.
Correct.
That's one of the things that we're.
So in that case, I'd actually recommend they don't buy the universal kit, right? If you want to build it yourself, the universal kit wasn't really designed like for contractors in mind, because you guys have so much more stringent things you have to do. Like Greg was saying, if you have to use fused disconnects, or if you're putting this for some, on like a 9K, the 1/2 inch whip is what you're gonna need. The 3/4 is gonna be huge compared to what you need. So what I'd actually recommend in your case is to buy it a la carte. Is that it?
Got a couple more for you.
All right.
Lighthouse Macro asks, on a multi-zone, if a leak is detected, does it shut off the compressor?
Yes. It'll shut off the compressor and it'll shut off all of your head units. It will shut down the compressor and it will initiate the leak code that I was just showing us a minute ago, where it will tell you that one unit has sensed a leak, and then you go and find what unit sensed the leak. Compressor shuts down, ball valve shuts, all the EEV shuts, no compressor operation at all.
Got another one for you.
Hit me.
How can we get the presentation? And they say they need a service manual.
Yes. Like I said, presentation, you can reach out to the dealer manager. She can send it to you. And service manuals. Service manuals, they are working on getting them in one centralized location. Currently, the best way to look up service manuals is to go to ACiQ.com, right? Or go to the portal. The portal itself will have the service manuals as well if you are a dealer. But ACiQ has a tech center where a lot of the resources and service manuals are. And you can go down to the tech center, and then you can go to what you're looking at, right? If you're looking at mini splits, you can go into mini splits, and you can see the single sources, the essentials, all of the resources that you could need as far as the service manuals, troubleshooting, service technical manuals, and you can click into those. If you find that one is missing, you can let ACiQ know, and they can get it for you. But if you ever need one, that's probably going to be the best way to find them outside of looking at the portal for the owners. If I were you, I'd recommend, of course, downloading them and keeping them with you, whether that's on your iPad or whatever it is. Your salesman normally can get them pretty quick too. That's obviously your first point of contact, but you can also reach out to ACiQ tech support. If you ever reach out to them and need a manual, they will find it. They will email it to you if you can't find it. You do not have to just sit there and do nothing. Our email is right there. It's tech support at ACiQ.com. We'll respond, we'll find it. If we don't have it, we'll let you know. If they're still working on it or anything, we can give you an update with that email. You can also call in. If you call in and ask any of the techs, they will be thrilled to provide you with a manual.
And then one more for you.
All right.
You got a question on how do we lower airflow?
On the mini splits or unitaries or both? We'll go both.
Let's go both.
Okay, on the mini splits, you're just going to change the fan speed itself. That's going to be the only way that you can change the airflow on those. That's obviously a lot easier than it is for the unitary units. Airflow is a little, like I said, on the unitary units, it's a little more convoluted, right? These are using constant airflow motors, so they want to maintain a certain amount of airflow as long as your static is within parameters. But I don't know if you were here and we talked about it briefly, but technically the remote that comes with the unitary units, if you go through the service manual at the beginning, it does show you there is a way to physically put it in engineering mode and change the airflow. However, I will caution you this is one of the biggest things I will say about doing that. You can lower it enough or increase it enough to cause issues with the system. You're taking out of its design parameters, so you are going to affect the system, but you can affect it so much that it could be a problem. So just be careful when you do it. And once again, if you're doing it just because you put a 5 ton on 2 tons of ductwork, it's not the solution, right? It's a Band-Aid to a bullet wound right there. You're going to end up hurting a lot more than you're helping. But yep, that is it. Cool.
The mini split's got the self-cleaning.
Yeah, that one will. So if we shut that one off right now, you can watch it go backwards. Oh, you have a question?
Yeah, so for a multi-zone, you may have already said this, but if there's a leak on one of the heads, what's the fastest way to like detect which head it is?
The unit will tell you.
Oh, okay.
So it'll tell you that code. I'll show you that at the very end. So it'll tell you at the at the head itself, you will see ECC1. That unit that's leaking will say ECC1. And then the other unit will say E8, where is it? There it is. ECC1 is the indoor unit refrigerant sensor detects the leakage in a multi-zone unit. So it'll lead you to the direction. So if you see ECC1, it's not gonna be that one, it's another one. Now, could multiple units be leaking? I guess it could. But if one leaks, all of the other ones are gonna get that ECC1. So you can trace it down to that way, right? We can see if it's the coil, we can see if it's the flares or whatever it is behind the wall or whatever. But that's gonna be the easiest way to identify that.
And then if you're working like in cold temperatures and they say to run in cool mode, would it not lock out on low ambient temp?
That's another thing. So like if you're technically trying to put it in heating and it's above 75 or 80, it's not gonna force it to do that. What's interesting is what I would reference for that is operating conditions. It's gonna be on that first slide. Technically, it can cool down to -13, right? And then you'll see heating, it will not heat above 75. It just won't. So the odds that you're gonna be in this condition where it won't run cooling is pretty slim. Like I said, that auto pipe feature is the only thing that I know of where it will like lock it out. Be aware, we have people, and this is a question Greg gets a lot, is like people want to use these for like server rooms and stuff like that. Their low ambient cooling is not meant for something like that. These are all made for comfort, right? So using them for like commercial applications is not really the way you should go. They don't have wind baffles. If they're on rooftops, they don't work the greatest. Unless you're gonna put, unless you're gonna put this unit in this room and then put that unit outside this wall, I would not recommend it using it for low ambient cooling. If you're gonna put it on the roof.
Basically would have had to get all third-party wind baffles and all those.
Oh yeah,
if they wanted to make it work, it was a bunch of, they had to get a bunch of other secondary stuff.
It's kind of a nightmare. So honestly, I recommend you just don't do it unless you're keeping the outdoor unit in somewhat of a heated environment, right? If it's an attic or something like that, then that's kind of possible. But we don't sell wind baffles and we don't recommend them for those commercial applications. But it shouldn't lock out in cooling, especially with what it's rated for, right? The hyperheat can even go down to that. But the only time I see it like lock out, like what you're saying, is 75 degrees or above. It will not run in heating. It does not want to. Now, could you technically take the return air or the ambient air temperature sensor and put it in a cup of ice water and force it to do it? You probably could. You trick it, you probably could. But just be aware that is the working temperature range of that unit. Cool. Well, it was nice meeting you guys. You guys have yourself a good one. If you have any questions, feel free to let us know. Yeah, you're welcome.